All right. Success. We are live on YouTube. So if anybody doesn't want their web camera or their audio streamed on YouTube, then you can disable the webcam and microphone. All right. Let me Okay. Can everybody hear me okay? I think you can. It was working.
Hopefully you can hear me good.
I can. You sound very good.
Good.
All right. So before I start everything, just saying here, Ian is on vacation at the moment. So I am the host. I am the person in charge here. So hopefully everything will go okay. This is my first time hosting one of these completely on my own. So apologies for any weirdness that happens. So welcome everybody to the Southwest Florida Tech Net. This is a weekly net that is sponsored by the Southwest Florida Tech Team, which is a new club starting out here in Fort Myers. Tonight we have a lot of topics. We have two main ones, and then during those two main ones, we will have the guy. Oh no, is Lee here?
Yes, he was.
He was.
I saw him.
You saw him. I see him.
Yeah, I'm here.
All right. All right. Yes, I can see you and you're here. All right.
The purple shirt.
Yep, I see you. Whenever it's in just a second here, we will I'll turn off the screen share and then you can start your screen share on your end. And that's how you can do your presentation. So this week we have two topics. The first one is NanoVNAs. NanoVNA is an antenna analyzer, and they're widely used by a lot of people, but they're kind of complicated. So we actually have Lee here, N4WYE, who is going to give us a presentation on how to use these. And I'm really excited for these because I have one borrowing from Ian, and I can make it work, but it has a lot of stuff that I don't know how to use. So I'm really looking forward to this. And these devices are relatively cheap. So if you're looking for a good analyzer, it's sort of the Baofeng of antenna analyzers, kind of. So this presentation is going to be really good, I think, for everybody here, because these devices are somewhat complicated, and this will be great. And then the second topic that we have is amateur television and cool amateur television things. So amateur television is where you transmit live video over radio waves using analog systems, not like digital, FaceTime, Skype kind of thing, but actually transmitting it directly, sort of like over the air TV, exactly like over the air TV. And I've put together some little projects I've done with it and some information about it together. So that's going to be the second topic. And then after that, we're going to go over, we don't have really any news for this week. I know of a few things that I may just speak about, but we don't have any main things to discuss. And then of course we'll just have the outro sort of slides after that, where we talk about the repeater and the local nets. That's the other thing. I'm going to talk a bit more in depth about some of the local nets that happen, because we do have some information in there about them, but we're actually going to make it a little bit more detailed. So without much more than that, I'm going to go ahead and turn it over to Lee. If you want to start your screen share, you are welcome to do so.
All righty. Let's see if we can figure out how to get it to go here.
I see it. It's working.
Now let me get it running here like it's supposed to. Okay. Can you see this slide?
Yes.
Yep, I can see it.
Is that the only slide you see?
No,
No.
we see the two slides. We see it says next slide.
36.
Okay.
Got
All right,
all your
that-
notes with it too.
That wasn't what I meant to put up there, but okay, let me back up.
Yeah, share the other screen.
Sharing your desktop right now.
Yeah, that's what I thought. Wanted to get this thing off the top here. Okay, here we go. Hang on just 1 second. Let me.
No problem.
Remember the discussion we had about the rehearsal?
Yeah, we should have done it.
I run.
I meant to call you so we could do it the other evening, but I completely forgot. So that's my fault. Sorry about
That's
that.
okay. That's okay. I'm just
Lee knew he could have called me. Lee and I have done this about 3 or 4 times now.
well, I was just, to be honest with you, I was just trying to make sure I had my notes up there. And I couldn't tell for sure if the if that version would that should be okay. But no, I can't see anything but that one slide.
I'm not familiar with the Mac keynotes, unfortunately.
Well, hang on, it can't be that difficult.
You know, you could do. I think you can when you share your screen, you might be able to share just like a selection box portion of the screen. Yeah, you can do it if you go to advanced and you do portion of screen. It'll let you actually use a little selector to just select, the one slide, and then you can have your notes up and everything. But we will only see
Okay,
one
all
bit.
right. I'll do that then.
Welcome everybody else who's joining here in the last few minutes. Ian is on vacation. I am the host, so bear with me when we have issues because he usually helps me sort stuff out like this. And it's my first time actually doing this on my own. But we have a good little show here planned, so it should go okay. Right now we're
radio. You dig your way through glitches and little problems.
Okay, what can you see now? Because I can't tell.
You haven't started sharing your screen, so we can't see anything yet.
Oh, that might help.
What happens?
Go to advanced, you said?
Yeah, you
Portion
go
of
to
the screen.
yeah.
Okay.
There we go.
There we go.
There we go.
Perfect.
Except it's not. I've got it, and you don't see the whole lower right-hand corner,
I
right?
see the title
Yeah, no, we can see it.
slide says why you need a NanoVNA.
Yeah, I just want to make sure you see.
There
the
we
whole-
go.
There you go. Now
That's
yeah, that's better.
that's even better right there.
Okay, that should. I think that's got it. Okay.
It
Of
looks
course, I
good.
don't see my notes, but that's okay. I can go without those. Okay. All right. Yeah, I think first of all, let me get it rolling here. Now, okay. First of all, thanks for the invitation, and I'll try to. I've got a slide deck here of about 30 slides. How's my audio, by the way?
Very good.
Very good.
Okay. I'd use this thing because it cuts down on the echo quite a bit. And I just wanted to make sure it was running out okay. Anyway, I'll go through the deck fairly quickly on the things that are just of minor interest here, and I'll try to focus on actually the operational side of it. Since some of you already have it, then that's where the focus is. I'm retired and living in Atlanta, actually in Marietta, and I started my ham career in Hawaii in 1957. And if you remember the sunspot cycles, 19 was probably the best one we've ever had. And that's when I got my license in Hawaii, and thoroughly enjoyed it. But like a lot of us, backed away a little bit during the work years and got back into it here in Atlanta a few years back. We retired to Hilton Head and decided the alligator in the backyard wasn't exactly what my wife had in mind. So we moved back to Atlanta. But in any case, I'm one of the founding members of the Raleigh Amateur Radio Society. We started that thing in '69, and I built the 0464 machine in Raleigh, the original 0464 machine. I've been in the high-tech industry for 40 years. And let's see here. Let's see if I can't keep this thing going here. Here's the outline. I won't go through it in detail since we got some more people here online. When I got here, I got back into ham radio and I thought, I really probably ought to start with my antennas, get a good software-defined radio, play with my antennas before I decide what to do about an amplifier. And I live in an HOA, and that's my antenna farm I've got up right now. I've gone through about probably 10 antennas total. Started out with the off-center fed, the red off-center fed dipole, then got into the in-fed half wave activity. You see there a pair of orthogonal in-wave in-fed half waves. And then I just started with a 40-meter loop, and I'm pleasantly surprised at how well that's doing. The in-feds are at about 65 feet. The 40-meter loop is about 40 feet.
Wow.
And I've got good oak trees to work with and a decent slingshot, so I can get them up there. The only problem I've got is I hope my wife doesn't see all the fishing line hanging up there during the winter time.
You must have done this just recently then.
In the last couple of years, yeah. A couple years ago, I was at one of the ham conventions, and I started looking around for an antenna analyzer to work on the antennas. And I thought to myself, maybe I'll just hang tight. I don't want to spend $300 on one.
Wow.
And so I thought, okay. Then the VNAs came along, the Nano VNAs, and basically I got into that. And it turns out, most of you probably already know it, but it turns out that it's a much more useful device than an SWR bridge or something like that, because you've got both a reflection mechanism on a single port, but you can also do transmission or through measurements. And when I build the LDMOS amp, I'm going to use this thing to tune the filter with on the output stages. But basically, a network analyzer, a vector network analyzer, is used to characterize RF devices, and it's been around for a long time. Here's a spread of what you'll see out there. The one on the left is about 50K on the used market.
Wow.
And the middle one is, a ways towards the $60 one. But I think the conversion, if you think about it, it's software-defined radio technology and software and firmware capabilities and some of the integrated circuits that this thing's really not that complicated. And it just took somebody with the vision of saying, hey, how do I take what I know about firmware, this hardware platform, and do something useful with it? And I think it's been an interesting journey. If you look inside the device, this is where it looks like. The DUT in the middle up there is a device under test. So it's whatever, if you got an antenna plugged into it or an amplifier plugged into it. But basically, it's a bunch of splitters, sources and receivers, and then digital signal processing. And the digital signal processing here is the same sort that's used in your cell phones, pretty much. So it's nothing really fancy. If you know the rest of the technology field out there. But if you look at it, these are the kinds of things you can do with it. If you take just the standard reflection stuff, single port, plug an antenna into it, certainly SWR, you can look at the load impedance. You can look at power splitters and diplexers, filter return loss, amplifier return loss, cable impedance, feed line length and distance to a fault. If you go through, you can look at filter measurements, look at balance, do phasing networks and amplifiers, and it becomes a much more useful device.
Repeater duplexers would be good for
I'm sorry?
Repeater duplexers.
Well, you can tuner duplexer, but the problem is you got limited dynamic range on this thing. And the real question is, if you're really trying to get isolation that you need in a duplexer, question is, do you really have the dynamic range to do it? I'm not sure you do.
Yeah.
Because if you think about this thing, it's got a source in there up to 300 megahertz, but to get to 1.5 gigs, it uses harmonics. And so the harmonics are not the amplitude of the fundamental. And as a result of that, you end up dropping, you'll see later on, the dynamic range drops down in the 30s and 40s dB range instead of 80 or 90 that I think you need for a duplexer. But anyway, it's the geek toy of last year, in my humble opinion. And it's like an RF multimeter. And for $60, it's a lot better than a multimeter. Although I think the old Simpson 270s are selling for about $60 now. This is the one I bought on Amazon, and I took a shot and said, okay, I know it's a Chinese clone. I know I could get bit, and I thought, okay, I'll just pay a little bit more for it and go through Amazon and take a shot at looking at reviews and things like that and see what I can do, and ended up getting a good one. So this is the one I've got. This thing, a little bit of background quickly. This started out as a kit in 2016 by a guy named Eddie 555, and he was a design engineer type and had some starting points. That some hams have already started down that path, and he just kind of started with that as a base, and then the cloning started off, and then a guy named Hugan 79, who's done the, if you will, the launch of reputable NanoVNAs that you can buy and believe you're going to get a reasonably good quality product. And he's extended it up to 1.5 gig. And he's also taking the firmware up and adding features and functionality to it. So you got a firmware lineage to work with. And the one he's done looks like the leader of the pack in terms of software resources and what the open source software family or communities is supporting. As an example, the larger screens are already here. They're going to 3 gig. That's a slightly different platform just to get the noise performance up. They're going to be putting on the firmware. In fact, I think the firmware is already in trial now to do screen capture. Because one of the problems you have with this device is once you turn it off, you've lost the data. And unless you plug it into a phone, an Android phone or a PC, you don't have any way to capture the data except for using your camera on your cell phone, which is what I've done. And that works okay. I mean, how many of us would take a PC out to an antenna anyway?
Yeah.
Right? I mean, so this thing to me has turned out to be more useful than I thought. And a lot of the detractors who say, yeah, but it doesn't do this. Well, if you look at the new H4 NanoVNAs, that's the nomenclature for Hugan's 4-inch version of the 2.8 version, 2.8 inch I've got. The SD card connector is starting to come on the new ones. So you're going to be able to do a screen capture with an SD card, and the firmware is coming to support it. So the one last, I think critical feature is in the test side right now. Let's see. Okay, I'll keep going here pretty quickly. We don't need to go through the block diagram. Let's go towards the operational side. There's the schematic. As you can tell, for what it does, it's not a very complicated schematic. There's not that much there. It's basically ICs and bridges put in there. And here are the specs on it. If you look at it, the current H4 model goes to 1.5 gig, gives you a 0 dBm output. You got 1 milliwatt output. You can move it around a little bit, but not much. The dynamic range when you start out for the first 300 megahertz is 70 dB. That's pretty good. But if you look at the top end and when you get up to starting to tune, you know, some of the stuff you'd like to tune up in the higher frequencies, you're getting down to 60 and 40 dB dynamic range. So it's a little touchy up there. You got a USB interface on it. It's an internal battery. The battery lasts about 2 hours on mine. So it's halfway decent. You've probably heard about the 101 points, not enough points. You really can't get, you know, the detail you want. Well, you actually can. The newer versions of the firmware are starting to come out and have more points on it. You know, like 400 or something like that. And that's going to continue, I think.
Oh, wow.
But if you look at, let's say, your HF antenna and you go from, let's say, 50 kilohertz to 30 megs on one screen, the problem with the 100 points is in the 40 meter band, there are only 2 data points you're going to get data on in the whole 40 meter band. So that's the problem with the 100 points, because you got a wide screen, you're covering 30 megs, and the bands are pretty narrow. But if you go from 7.0 to 7.5, you got 100 points in the 40 meter band. So you don't need to worry about the fact that it only has 100 points, because you can just, you know, get the microscope out and turn it down to, you know, 500 kilohertz bandwidth or width, and you got 100 points in that 500 kilohertz. You got 4 traces, 4 markers, and 5 memories on the existing unit. And it's nice and stable. You can use it as a signal generator. It's stable enough to do that with.
Wow.
You may hear the term S parameters, and we'll talk about that a little bit just to give you some understanding of that if you don't have the background. But S parameters are what they call scattering parameters. And it's the same sort of thing of, well, let me get into it a little bit here, but let's do this first. Here's what the unit looks like. And by the way, here's what mine looks like. There it is. It's got a plastic case on it. Okay, and there's the connector. But basically, if you look on the left-hand side, one of the things that scares a lot of people is that when you first turn the unit on, here you are, a new proud owner of something that you feel like's a good deal, and the screen looks like that when you turn it on. So it scares people that, like, I got a bad clone. Well, what happens is those are just receivers and sources turned on, and all the screens lit up so you can see everything. And that's noise. A lot of the cyan colored trace there is just noise in one of the detectors. So that's just what it looks like when you turn it on, but don't let that frighten you. If you look at the controls, you know, you got a USB port, power LED, power switch, a system LED gives you some idea. And then you got a rocker wheel on top, which is a little tricky, but you have a touch screen and you can use remember your old Palm Pilot stylus? You can use that kind of stylus on this, or you can use a pencil or whatever you want to. It's not a real easy touch screen, but you can do it. Problem is, on a 2.8 screen, your finger's pretty fat. Yeah. But if you look at it, these are the 2 main screens you see pop up. The first one there, you'll notice it goes, the bottom part of it, you can't read it, but it goes from 4 megs to 900 megs on this particular one. And on the right-hand side, you see the beginning of the menu. The displays shows you traces, formats, scales, and channels. Then the marker You can add markers, you can make them a particular function, and you can search for markers. On the stimulus, you can put the start and stop, like on the beginning of the band and the end of the band, any frequency range you want, or you can put a center of the band and put how much span you want. So you can do it either one of the two ways. Then there's a calibration mechanism. You've probably heard bad things about the calibration one, but don't let that scare you, because all they're trying to do is to take out all of the variables and make sure that the readings that you get are accurate. I haven't calibrated mine in probably 6 months. Okay, I just use it like it is, because I'm using 50 kilohertz to 30 megahertz. And so I've calibrated it for that frequency band, and I haven't noticed any problems with the accuracy at all. And I've done the calibration over again, and it's dead on. So I haven't worried about it. The screen down here below shows you how to enter numbers and multipliers and things like that as you're putting frequencies in, stuff like that. But that's the user interface. It's really not tough. There's a little learning curve, but once you learn it, it's not a big deal at all. For instance, if I want to do SWR, I turn mine on, and it goes to that screen, and there's my in-fed antenna. So it's set up, it's calibrated, it's ready to roll, and I got it on 3 to 30 megahertz, or 50 kilohertz to 30 megahertz, and I put that in memory and calibrated for it. So whenever I want to use on one of my HF antennas, I don't have to calibrate. I can just go directly into the measurement, and I've got it set up for SWR measurement when it turns on from scratch. So there's the menu tree of walking it through the menu, but this is a software guy's version of how it works. It's not how to measure SWR. So you have to know how to walk through this thing. But basically, this is the diagram that would allow you to walk through doing a measurement that you might want to do, and show you how to get to it if you get stuck. Let's see here. Before each set of measurements, you need to configure the VNA by what kind of traces do you want. If you're doing SWR, you only need one trace for SWR. You got 4 traces to work with. What kind of format do you want? You want SWR? You want return loss? Do you want a Smith chart? You know, what kind of format would you like to see the data in? Scale, you can set the scales so that, you know, if you want to see details of SWR, you can move the 2 to 1 line and 3 to 1 line up and give you some more space to see what the scales are. So they're all flexible. On the stimulus, you set the frequency range, and then the calibrate. Can you see my marker, my cursor?
Yeah.
Oh,
Yeah.
This is an absolute gem right here. It's on the references at the end of the slides, but this guy did a super job of taking a beginner's guide to a NanoVNA and writing it down in whatever detail you want to go into. I'll hang tight for just a second. I want to write it down.
Absolute Beginner's Guide to NanoVNA, Martin Svako.
I think the guy's from Slovenia, I believe, but he did a wonderful job on it. Okay, here's the calibration side. And basically, if you look on the left-hand side of the screen there's a bunch of letters, and I put them on the left side of this screen right here. And they are right here on your screen. Oops. Let me back up here. They are right here. And basically, there's a little trick here. Notice that's a capital C. That says it's calibrated for the frequency range that you're using. If you go to a different range and it's not calibrated, that goes to a lowercase c.
Oh,
Okay, so it'll tell you if it's calibrated for the range you're using. All right, and then basically these are the kinds of things that you're measuring: directivity, reflection, source, matching of the source, transmission tracking, and then isolation. Those are the kinds of things that you go through with an open, short, and load on the port as you go through it. And you put them on one at a time and just walk through the menu, and bang, it's calibrated. And the basic idea here is, if you look at a Smith chart, for those of you who know Smith charts, you know that a 50 ohm point that's purely resistive is right in the middle of a Smith chart. Okay, and so they're trying to make sure the cursor is sitting right there. And then on one side of the Smith chart, let's say over here, it's either short or open, and on this side it's either open or short. I forget which is which. Okay. All right. I'll hit the right button here in a minute. Oh, what's that? Can't tell why it's doing that. I'm just going to step it through manually here just to make sure. Okay, here's an SWR measurement. This is what the screen looks like. We'll walk through it real quickly. See, it says SWR.
mm-hmm.
Scale of 1. This is 2 to 1. This is 3 to 1, and that's 4 to 1. So the scale is one scale. One integer of SWR is one line up. Okay, you can change that and make it a quarter if you do. You want to make this a quarter, a half, 3/4, and SWR of 2 to 1. You can do that. But right on this one, this is 1 to 1 on the bottom. This is an in-fed half wave antenna, and this is 2 to 1. Okay, so it's a pretty decent performing antenna. I've come to love those things. I've built the 49 to 1 transformers and I like it a lot. One of the only problems I had with it when I put it up was I put it up at 65 feet and I didn't want to take it back down, and notice my resonant point is at 6.9. So it's outside the 40 meter band. But as it turns out, it didn't matter because the SWR is still low enough that 7.3 was not a problem. Okay, but here's the frequency of the marker. Okay.
That's what a little arrow is.
Yeah, there's the arrow right there. Okay. And this is the starting point on this side of the screen at 50 kilohertz. And this is the end over here at 30 megahertz. So you can see there's a 40 meter spot right there. There's 20, 15, 10.
10.
Oh wow! Now that's really nice.
That shows you the.
And so it shows you a lot in one chart. And now you want detail. Okay. Let me take this chart to the next step. All right.
You must have an 80 meter in-fed half wave. Is that right?
Let's see.
Is it 130 feet long?
I don't remember which one this was now that I think about it. I had an 80 meter, but I didn't think this was it. Okay, here's
Because you've got low SWR points down below 7 megahertz.
right. But I think that's the answer is I don't know for sure.
Don't let me sidetrack you.
Let's see here. This thing should be running. What I wanted to show you here was a little bit about how to interface with the screen. Okay, and in just a minute you'll see it come up.
You can see
The video is running. Yep.
Yeah, we can see the little lines wiggling.
Yeah, basically, let's see. Can you see that note coming up on the bottom of the screen?
Yeah, I see it. I have 2.
Okay.
videos, my Nano
Then I got to
Vna.
figure out how to put that screen back where it's supposed to be here.
Better.
I've gotten it out of the play mode somehow, and I just don't want to take a chance on screwing it up. Okay.
That looks good.
All right. Okay, you see it wiggling a little bit right here.
Yep.
So the video is running, and the idea here is basically to show you what it looks like as you start to use the device. Okay, it'll show you what the menu screens look like as they come up.
Right now, there's only one. What is that? So the little
The
lines at
marker?
the top. Yeah, the marker. There's only one marker
That's only
enabled.
one marker. Yeah, I didn't put a bunch of markers in there, but you can put them in there. Now I wonder why. Oh, here it comes. Okay. And I'm recalling what I did is this is a plot of return loss. For some of you who know what return loss is, basically it is the loss of the transmission towards the load and how much of it returns. So it's return loss, if you think about it that way. Okay. And this is 0 return loss, and this is now 10, 20, 35 dB return loss. And that's, see where the SWR is down here?
Mm-hmm.
This is 7 megahertz right here, by the way. This is 6 over here, and this is 8. So there's the 40 meter band. Now we'll go to 20. Okay. You can see though, you get a much better idea. You get more precision with return loss than you do on SWR on the previous chart and on some of the others. You get a better idea of where the real resonant point is.
Oh yeah, there are more steps in there.
The one you saw before had a lot more detail to it. The next one's going to go to 15. But you see how you take the 30 meg slot. I put in 13.5 to 14.5. And on this one, I'm putting in, let's see, 20 megs to 22 megs. We'll see how deep that notch is. You don't see that on the SWR so much, but this gives you a better idea.
So down, so when it's going down, that's more reflection?
No, that's less reflection.
Less reflection.
That's like 1% reflection there, right? Just like SWR. When it's down like this, that's less reflection.
Yeah.
Okay.
So it's negative 40 dB.
Right.
Okay.
And you want to make sure you got at least 15 or 20 dB on a resonant point that you're trying to use. Otherwise, the Q of your antenna is not high enough to do you a lot of good. And here's 10 meters. So it gives you, look at this antenna. That's 1.6 to 1.7 covering the whole 10 meter band. And you just saw an end fed that covered everything I wanted to cover. Frequency wise, I didn't have to worry about CW versus sideband on 75 or 80, because I chose to do a 40 meter antenna, and I just moved it up a little bit so I could get the whole 10 meter band. Now here's a Smith chart. Okay, remember I said 50 ohms is right in the middle? There's 50 ohms right there. And notice it says basically 49.8 ohms and 1.65 nanofarads. So that's the actual impedance right there on that antenna. And 1 to 3 is the same as 1 to 3 here. So that is the frequency of 28 to 29.7, I think, or something, wherever the band is up there. So that gives you an idea what a Smith chart does for you. Okay. Okay, so there's that one. Now let's move to the next one. Bartley, I'm sorry if you can hear my dog. I apologize. I'll try to quieten him down. He has one of his toys he's playing with, and he's decided he's going to be my friend for the night, I think. Okay, on this one, let's see.
Is that the same clip, or is it?
No, it's a different cut at it.
Oh, okay.
Okay. The answer was I was on the same one, and I didn't mean to be.
Oh. At the end, are you going to be available for taking questions?
Oh, sure.
Because I know I have
not a problem at all.
I'm going to have a couple.
Okay. All right. And On this one, the idea here was to walk you through setting these screens up. You want to set a set of, let me back, well, I don't know if I could back it up without screwing it up. So stop. There's the 8 megahertz side. So you see that goes from 6 to 8. So I just changed the scale by tapping on the screen, and I can move the cursor around and look in the upper right-hand corner, you'll see where it is.
You can also use the little rocker switch on the top to go up and down, right?
Yeah, you can do that. You can do that. But it's easier, to me, I found it easier to put a pointer on there because, you know, getting the marker on the right spot, because the marker has got multiple dimensions to it, not just rocking, but up and down as well. And I found it difficult to manage it. And there's a noise here, and I had to, I'm moving it over, moving the detector over and changing the channel, showing the reflection. There's the return loss. Okay. And again, you get a much better idea of where the resonant point is. So
wow, that's really,
yeah, it's a lot more precision. And you can move it around and there and find out where it is. There's a 6.980 you saw before on the NFED plot. So that's one way you can use it. And here's again is the Smith chart, and you can actually move this one around as well. You can take any one of those 3 cursor markers, put the cursor on it, and the others will move with it. So you can see the impedance going down to 45 ohms. Okay, so there's that. Here's my off-center fed antenna, and that's what it looks like on 80, 40, and 20. Again, using the same sort of methodology I just showed you on the screens. Here's a 40-meter dipole. You can see the real high Q dipole, and there's 15 meters. And there's 40 meter right there, Smith chart version of 40 meters. Okay. See, it's above 2 to 1 at the band edges. That was my attic antenna, the first one I put up, by the way. Here's taking a look at that NFED, the SWR numbers that we just saw. Remember that 6.9? That was 1.09 SWR. And if you look over here, here's the ICOM 7300. And you can see it coming down at the bottom end of the band, down to, you know, approaching 1 to 1. Okay, so this is a comparison of what you see here and what the 7300 SWR graph showed. Okay, so there's covering the whole 10-meter band, and it's below 1.5 in the whole 10-meter band. And there's 20. There's no, it's 15. There's 20, and there's 40. Okay, let's see. We don't need to go through that one, I don't think. Here's an interesting one, by the way. I got into looking at delta loops. As you can tell, I'm moving from an attic dipole to NFEDs to off-center, actually off-center fed next, NFEDs, and now starting to look at loops. This is probably, I did all these measurements in probably about 15 minutes. Okay, so I'm outside at the antenna. I'm looking at it from 50 kilohertz to 30 megahertz, and that's what you'd expect. 20, there's 20 meters right there. Okay. Then if you look at it 13 to 15 megahertz, there's 20 meter, and 14's right there, okay? And then you look at the Smith chart, you can tell that, okay, it's not at 50 ohms, but it's not too far out of whack, but it's higher impedance than 50 ohms. So you got to move it back to the left. So I used a matching section, a 75 ohm matching section. And then I thought, okay, how do I know how long to make that matching section? Because I don't even know the velocity factor of the coax I'm going to use to do it with. Because I had a chunk of a 75 ohm CATV coax, and I had no clue what it was like. Well, I hooked it up to the VNA and basically moved the frequency around to the frequency I wanted, and then started cutting it. Okay, and it was sitting up here, and I started cutting it, and I went back here, and I'm halfway around the Smith chart. Okay, well, that's a quarter wave stub. Okay, by definition. Okay, so I was able to use this thing and get by having to figure out what all the numbers had to be, because I didn't know what the coax was, and I didn't want to go buy a piece of coax. So looking at the matching section, you see the 100 ohm point here, it is now at 50 ohms. So I actually took the NanoVNA off the antenna and went to the end of the matching section, not in the shack, but at the end of the matching section. And you can see it sitting right there at 50 ohms. Okay. Notice the SWR. That moved, and you get a better sense of what you're looking with here as well. And if you go inside the shack, here's what it looks like. 50 to 30 megahertz. And there's it's a 20-meter antenna, so there it is. And there's what it looks like inside the shack. All right, the SWR is a little better because I got some loss in the coax, so it naturally looks better. That's really what the impedance is right there, SWR. And there's a Smith chart right in the middle again. So there's an example of taking an antenna at the antenna itself, putting a matching section or something on it, could be a tuner, could be whatever you want to have on it, and then going in the shack and measuring it. And I did all that in just, not very long at all. So that's the quality of stuff you can do with these Nano VNAs. You can also look at filters. Here's a 88 to 108 band stop filter. Get rid of FM noise if you're using an SDR kind of receiver. You might get overloaded with a strong FM station. So here's the notch to get rid of it.
Wow.
And if you look at here's what the Smith chart looks like, return loss, and anything else you want to take a look at. But if you look at this right here, the middle of the passband, that's I think I can't read the number, but yeah, it's 96 megahertz. I got to get back again. Sorry about that. I got excited. Okay. Another thing you can do is if you want to look at your 2 meter or 6 meter or 432 antenna, you can actually take a piece of coax, take the VNA, get outside the near field of the antenna, rotate the antenna, and plot the pattern of gain on the antenna.
Whoa.
Okay.
Yep. Cool.
Because don't forget, you got two connectors on this thing. One's the transmitter, one's the source, and one's a receiver. Okay. So you put the antenna in the middle, and that's a plot of it right there.
That's really cool.
Here's a time domain reflectometer. If you got a 100-foot tower and you want to know where the break in the coax is, you can find it before you go up the tower. Okay, I won't get into this one, but Nano Vna Saver is a software package that goes on the PC, and you can hear the screens. You can see where you can separate the screens. You don't have one overlaid on the other. So that's the advantage of this. You're not limited to 100 points, so you can get a lot more detail. And you can basically, here's the set of features. I won't go into them a lot because, to be honest with you, I haven't found it necessary to go find a PC and hook it up to do this, because I can do what I want to do with it. And I've gone through about 8 antennas now with it. So I haven't found the need to go do this yet. But it's good software. It's easy to operate. It's as far as I know, it's open source software.
Yeah.
Okay. Here's some useful sources and links that might be helpful. And I can I'll send this. What's an easy way to get this to everybody?
If you put it in the Zoom chat.
Easy for you to say.
Yeah, there you go. I wonder if that'll work if you just pop that whole thing in there.
Well, I'm on a Mac, so it probably will. I'm kidding you, PC guys.
Gosh, I was gonna start saying some things.
Let me find chat up here. Where'd it go? Where'd it go? Where'd it go?
When you're sharing the screen, it's kind of hard to find it. There we go. Well, that worked great.
Okay. Now you know why I use a Mac. Okay. All right. So anyway, here's an introductory video that's pretty good. But there's 10,000 videos out there now, and you can find a lot of them. There's a Groups.io forum out there. This again is the one I told you about. He's on version 1.6 now of this, and so get the latest one. The H4 is the only one to get right now, I think, if you're going to buy one. And here's the guy who wrote the software for the Nano Vna Saver. And here's an introductory chart for a Smith chart if you want to, get crazy.
I probably need to watch that.
Well, it's useful. It's useful. Okay, let's see. Where am I here? Yeah, here's the wiki and the Groups.io stuff. You'll notice there are two VNAs on here. One is the one you'd expect, and here's a new one. And this one goes up to about 3 gig, but it's a different platform altogether. But if I'm not mistaken, the firmware coming out supports them both. Don't quote me on that because I'm not sure. There's lots of YouTube videos out there, and basically, the Nano VNA is really a powerful RF tool. It'll do most of what that $50,000 machine will do. Maybe not as well, but well enough for what we're trying to do with it. It's an open architecture on the software side. GitHub is the repository. And by the way, my daughter-in-law used to be the privacy lawyer for GitHub.
Oh, wow.
And by the way, here's the source that I would recommend, and that's RNL. Everybody I know that's bought one from RNL has been satisfied with it, and these guys will back it up from what I've seen so far. The 2.8 inches, $60, and the 4 inches is $90. If you're going to buy one, I'd buy the 4-inch. This screen's a little bit small, but it does get the job done. If you're going to buy one new, I'd get that one. And by the way, here's my azimuth plot of the results of all my antenna work. This is a plot of showing 20 meters, the loop versus the end feds, which are orthogonal. Okay, so I cover basically pretty well any azimuth I want to. And if you look at this is measured in S units, 1 S unit, 2 S units, and 3 S units, and you can see the loop will beat the end fed facing Europe by 3 S units. And the end fed is 25 feet higher.
These standard S units like you would see on a radio.
Yeah, these are like 6 dB S units.
Yeah.
I call them 3, but this is really, let me back up. This is what I did was, this turned out to be, it's a lot closer to 6 than 3. Okay. Because I had to interpolate a little bit given the ICOM 7300 that I'm using to get this plot right. So it's kind of part way, but it's a lot closer to 6 than it is 3. But you'll see that only in certain areas did the end feds even get close. And that's only 1 S unit difference. So I turned out to be a loop guy.
Wow.
I couldn't believe it. Now on 40, it's not quite that one-sided. It's more even than this looks on 40 meters. Okay, I got a test question for you. Now that you've gone through the thing, I want you to tell me what kind of an antenna that is. The other four, by the way, just a heads up, the other 4 clubs that I've given this presentation to got the answer. Okay. Let me know if you want a hint.
Don't tell us that. I'm.
All right, think about a Smith chart for just a minute. Remember 50 ohms is in the middle?
Mhm.
Notice that antenna goes from 50 kilohertz to 900 megahertz and it stays close to the middle.
Sounds like a dummy load to me.
Nope, dummy load wouldn't do that. Dummy
No.
load would be a spot in the middle.
Oh,
Disco?
That's it.
I'm gonna say
It's a disco.
discone.
Yeah.
Wow, that's really impressive. I didn't expect the discone to actually be that stable.
Look at the SWR curve. I didn't either.
I know, that's amazing.
Wow. I'm about to build one for VHF here.
That was the first antenna I put up in the attic was a discone because I didn't have enough time to get the dipole up. And so anyway. Okay. Any questions? I hope I didn't run too long.
No, you were perfect. I have a question. Well, here, let me open it up to anyone else who has any questions for
Sure.
Lee. Anybody else have any? If not, I'm going to go ahead and ask mine. All right, I guess I'm the only one with questions then, which means you did a really good job. The main question I have is, so you were mentioning calibration and it being calibrated for a specific band. I have a NanoVNA here that I am borrowing from Ian, and I don't have the calibration, the little ends that you put on it. I don't have those.
Okay.
And I believe it was calibrated once. So I mainly use this on UHF, but if I put this on another band and it hasn't been calibrated for that band, am I going to get highly inaccurate readings?
The answer is I don't know, but let me give you a way to mitigate that. Have you got a dummy load that's good?
I don't have any dummy loads. I need to get one.
You need a dummy load.
I know I need one.
Go buy a carbon resistor at 51 ohms. Okay. And make sure it sits in the middle of the Smith chart. And that's close enough.
Okay.
I mean, that's where you want your accuracy anyways at the 50 ohm point. If you're at 200 ohms or 300 ohms, that'll at least mitigate the problem, but it won't solve it.
So without the calibration being done, though, my question is, and how crucial is the calibration itself? If I use it in this state where it's probably never been calibrated, and I go take a measurement at 40 meters, and then I go take a measurement at 70 centimeters, are the results going to be, incredibly off from what they should be? Is it actually a reliable source of information without ever being calibrated? Like, because I didn't know you had to calibrate it for different bands, because you're saying you had different memories for different bands.
Well, you have different RF performance.
You have different.
Think about it. You're going from 10 kilohertz to a gigahertz and a half with semiconductors and a printed circuit board and splitters and all that stuff. To expect the same kind of noise performance over that band, you're just not going to get it.
No, I know.
Okay.
It's going to be wildly. I guess it's going to be.
And I think the linearity is going to be a little bit better. So it depends on you just trying to do SWR.
Yeah, pretty much. Just SWR, and then of course the impedance. Those are the two main ones.
I would before I'd trust it, I'd at least make sure on 50 ohms that you got a shot.
Okay.
Get a 50 ohm non-inductive resistor and try it.
Okay.
Okay. And then at least you got a first order approximation that it might be good enough to squeak by. Certainly you'll be able to tell, what the resonant points are on the antenna frequency wise.
Or
so you can
just
tell
make
where
him
minimum SWR is.
give you the calibration slugs.
Yeah, I think he lost him though.
You can buy them on Amazon and have them tomorrow.
That idiot.
Oh, now he's not here. You're gonna trash talk.
You can buy them on Amazon.
Okay,
Sam, I would trash talk him if he was here too. You know that.
yeah. Yeah, I need to get me the set of calibration points then, because I've been, especially when I try and use this up on the higher frequencies where it's more important. I've been using this, my antenna could be different from what well, see, the thing is the readings actually correspond pretty well to the MFJ analyzer that we have on the 2 meter band and below. It actually, the readings seem to be almost identical. So at least it's working pretty well for that. But since the MFJ reader we have doesn't go up to UHF, this is kind of all I've had. But since I haven't really calibrated it, I need to do that. Yeah, those 3 little pieces there.
Well, think about it. This one's an open. So you can
do
forget
that one.
about that. You don't need that one. Okay.
I could make a short, probably.
Exactly. You can make a short, but you need the load. You need the 50 ohm load, which you can use as a resistor. You don't need a 2 gigahertz resistor.
No.
Depends on how far you want to go up, and being non-inductive.
So the kind of resistor I need was what to test that?
You need a non-inductive resistor.
50 ohm composition resistor. Yeah.
Yeah, carbon composition is good. There's some metal. There may be some metal ones you can get too. Another thing might be to go ahead and buy an SMT with no leads on it, and just mount that in a small connector. That would be probably the most accurate one, because that's what these things really are. They've got SMT components in those connectors.
Joseph, you might be able to go into the swap shop, in our swap shop, and find something like this. This is off a Bird watt meter. It's a 10 watt dummy load.
Yeah, something like that.
Yeah.
But then he's going to have the issue of trying to go from that end connector or whatever you've got down to that SMA. You can buy these little SMA dummy loads and the open and the short off eBay.
You can buy the connector adapters easily.
So those aren't going to interfere with the readings, though, are they?
Well, the point of the calibration is that you can make them so they're not part of the reading, because you calibrate outside of that plane, if you will. For instance, a lot of people, let me show you something. One of the things that you need to have is what they call connector savers, okay? Because notice these things stick out a long way on here.
Mm-hmm.
These actually just come off.
Oh, so you have like a little. Oh, I have one of those.
It'd be like an SMA or something.
It's just like it's just a little. It
Just an
extends it
extender.
by 1.
Yeah. But basically what happens is if you keep spinning the calibration pins on the connector that's in the VNA, you're going to take off the gold, because there's not much gold on there. Because if you put the calibration thing on there and spin it, it's a metal pin spinning in the female connector. So if you put these things on, okay, the gold wears out, you replace the $2 part. So that's why I put these on here, and it's really a useful thing. But I'm getting to your point now. Let's say you had 2 cables with end connectors on it, and that's what you were going to connect to. All right.
Okay.
You would do your calibration of your short and your load at the end of those stub cables.
And they could be.
So then what you put on those cables
long,
has
they
been
could be 10
calibrated
feet long.
into what the readings are.
Right. Okay, I get it.
Okay. So for instance, if you wanted to know what your antenna looked like at the antenna, if you do the calibration on the end of the coax going to the antenna with these loads, if you do the calibration out there, it'll read what the antenna shows you in the shack. Because you've taken that out of you've made that part of the calibration position of the device.
I see. So we're in a different. I see. Okay. I'm definitely gonna need to see some of these guides.
Well, the videos are pretty good, and there's probably, I bet you there's 500 videos out there. So, if you want to know how to calibrate it, just type in NanoVNA calibration routine on YouTube and you'll have 50 videos.
Yeah.
So
that answers my question pretty good.
Okay.
Put that in there.
Good.
Okay. So anyone else have any questions? Well, see, that's what I'm going to tell you what Ian says. He says, if you don't get any questions, it either means you did bad or you did good. But personally, I think you did really, really good.
Well, I hope it's helpful.
What in-fed half-wave antenna do you have? Just curious.
I'm sorry?
What in-fed half-wave antennas do you have?
I built them.
You built them? Yeah.
Well, let me give you one sentence that might be helpful. Have you ever heard of a Facebook page? The guy's name, the author's name is Steve Ellington.
Oh yeah.
Okay.
Steve Ellington. N4LQ.
Yep. His page is where I got the details to wind the transformers. And
that's what I've done here too.
Yeah, I mean they're really good. I wouldn't buy one. I wouldn't spend the money to buy one. I've probably got 50 toroid cores now though.
I've got a commercial model from my antennas, and then I've got one that I built.
Yeah,
which is the 40 meter. I think the one that I built actually works better than the commercial model.
It wouldn't surprise me at all.
Yeah.
Wouldn't surprise me at all. The one thing I did have to do was I had to take a turn off the secondary for the high-powered version where you use the 52 cores.
Yeah.
The 352 cores.
Oh, you use 52 cores. Okay.
Well, you use if you're trying to get power on that MFED, if you want to run a kilowatt, you need the 43 cores. If you run two of them, they won't handle that kind of power.
Saturate. Yeah. Okay.
And but if you take 3 cores and stack them up, I needed to take one turn off to get the 10-meter SWR down.
Yeah. Okay.
But other than that, I did a straight copy of what Steve recommended. And I've talked to him a number of times, and
Yeah.
I think you're right. You can build one that's better than what you can buy.
Yeah, I definitely think that now,
Yeah.
because I built mine, and I've worked Croatia and all over the place with it during contests on phone and on CW, and it's
Oh,
just
yeah.
20 feet above the ground.
Yep. And I run 100 watts. I don't run any more power than that.
Yeah,
I figured I'd spend all my time and money on the antennas first before I decided to go build an LD MOS solid state amp, which is my next project.
Yeah, I don't plan on building an amp, so I'm looking at getting me a hex beam, but that may be
There's an idea.
Yeah, so
I'm in an HOA, so hex beam is probably a little bit something I couldn't do.
yeah, you have to tell them
Hang
it's about
clothes on it,
down
make the
umbrella.
clothesline.
That's my big umbrella.
Yeah.
Yeah. I got to have an umbrella like that here in Florida with all the rain.
Clothesline.
Yeah, there you go.
Yeah, or as the Brits would say, a washing line.
Hang some shirts from it.
Yeah,
There you go. Hang your underwear from it, and nobody will say a word.
Isn't there I think there's some kind of rules somewhere in America, but it says you cannot prohibit anyone from putting up a clothesline. So if you tell them that it is a clothesline, then they, even in an HOA, as long as they can't prove otherwise, then they won't be able to shut you down, because there's nothing that says they have to let you put an antenna up.
It's hard to argue with a 50-foot clothesline.
Yeah.
That's 12 foot off the ground.
Right.
up there. I don't like my clothes. I haven't got struck by lightning. Yeah.
Why is your clothesline 60 feet in the air? Yeah, man, that wouldn't work too well, I guess.
That's so that it wouldn't be in the shade of the trees.
Yeah.
And the birds wouldn't bomb it.
All right. Well, it's 9:09, and so what we're gonna do is we're gonna have a short little break here. We're gonna probably have about a 5-minute break. So if anybody needs to use the restroom or get a drink or a snack or something, you can. And when we come back, let me share my screen here. Oh dear, I seem to have misplaced my, here, let me go back to this. We're going to do amateur television.
Oh, cool.
This is something that I don't hear a lot about in ham radio. Not many people do it. It's a very, very kind of rare thing. And it's basically just analog video and audio transmission over the airwaves, just like over the air television, where you put up an antenna outside. It's the amateur version of a TV station. And there's a lot of different equipment you can use, but recently, in these recent last maybe about 10 years or so, it's actually taken a very interesting twist that almost takes it outside of the realm of amateurs and or amateur radio operators, but into the general public. So it's an interesting thing, and I've put together a bunch of information about it, and I'm going to talk about it, and I'm also going to share what I've done with the project and what I've done with the video transmission systems, and I think they're pretty cool, and I have a few videos and some pictures to show. So I think it'll be pretty cool. It's one of my favorite things to do with radios is transmit video with live videos, like really cool to me. So we're gonna go through that after we have a break for about 5 or so minutes. I'm gonna go get a drink of water, and then I will be back. So during that time, anybody, y'all can do whatever you want. But I'm gonna go, and I'll be back in about 5 minutes.
All right. That's what I'm going to do. See you in a few. Or
All right. We are back on Southwest Florida Tech Net. And we are going to talk about some amateur television. I was getting a couple little things here to show when we get into this. All right. So amateur television is where you transmit video, analog video, over using the radio waves. And there are some digital ways to do it, actually, but the main use behind it is analog. And it uses, it can be used in a lot of things like weather balloons, which is one of the really cool applications when they set up a weather balloon that has like APRS on it, or, you know, they'll put up like a repeater balloon. That's another really cool thing people do is they, you know, set up a balloon that's got a repeater in it. And so they can like contact each other like 8 absurd distances on VHF and UHF, which is pretty cool. But W8, this club here actually did it. They put a camera in it. So it was transmitting video from it, not using any internet, not using the cell tower, actual RF over the air. And you can see here on the left what it kind of looks like too, coming in over a normal television channel. So some people say amateur television, they also think slow scan TV. And it is technically amateur television, but it's a lot different than what we're going to be talking about tonight. We're going to be talking about fast scan TV. Another word for amateur television is fast scan TV. It's what they used when the Apollo mission went to the moon and they transmitted the video down. It was using fast scan TV. So that's what this is, and that's what over the air, you know, broadcast TV as well. It goes up to about 30 frames per second or 30 hertz, and SSTV, of course, it just like goes over the airwaves and takes about, you know, 60 seconds to fill in the picture. They encode audio with the video. A lot of the time it'll have a little carrier on the side where they send the high definition audio. And it uses different analog video standards like NTSC and PAL. So it's not, you know, digital DRM or anything like that where when they transmit it from the television station. This is actually just the NTSC signal. And it's actually quite interesting because you can use with the equipment that you get to do this, you can use certain things. Like if you have an old camcorder that can output in the AV format with where it has the little RCA plug, that video signal coming over those 2 wires is the same thing that's being used here. So any audio visual output will work with this, and input as well. If you have a receiver that outputs in the RCA cable, that's what it's using is just the analog stuff. It's got a certain amount. There's not as much frequencies you can do with amateur television compared to like broadcast TV, mostly because it uses a lot of bandwidth. So we can't use it on HF because it would use up about 6 or so megahertz for one stream of video. So you'd be using up multiple bands on HF with a 6 megahertz carrier. The lowest we can use it is 70 centimeter. We can't use 2 meter either because that's not 6 megahertz wide. And if you did, you'd be covering up everything. 70 centimeter is the only one that has actually enough room in it to be used. And that's the other thing is because between channels 13 and 14 is where the 70 centimeter hand band actually sits. I believe. I think I'm saying that right. And that's it can actually be tuned to using a normal television tuner. So they're not so common anymore, but back when people used to put up their VHF Yagis on their roofs to pick up, their UHF Yagi antennas on the roof to pick up their signals, you can actually use the same little TV receiver boxes to get your own little transmissions, which is kind of interesting. The next up, these are the most common frequency bands. So when you're buying equipment, you can only really find equipment that transmits video on these bands, and the second lowest one is 900 megahertz. That's you can get them in little modules that are about this big, and they cost about $100 for a receiver and a transmitter. 900 megahertz is pretty much the lowest that you can actually find transmitters for. I have yet to find a 70 centimeter transmitter. 1.2 gigahertz is another one. There's benefits and drawbacks to each band. So 70 centimeter has the benefit of being a lower frequency, so it'll actually penetrate stuff better. That's the only real benefit. The major downside is antenna size, and this is going to become relevant later when I get into what amateur television is most widely used for in present times. So 900 megahertz penetrates not as good as 70 centimeter, but it does do it compared to the highest one, which is 5.8 gigahertz. The most common frequency used for amateur television and with the availability of equipment now is 5.8 gigahertz. With that being up in that high band, you get a lot of channels too. So there's like 40 or so channels available to be used on the 5.8 gigahertz band. And that's mostly the same for 2.4 gigahertz. But the problem with 2.4 gigahertz is that it is extremely crowded with a lot of Wi-Fi routers, and just almost every consumer electronic that has radio uses 2.4 gigahertz or 70 centimeter on the 433 megahertz band. But 2.4 is so overly crowded that it's not a good idea to use this band for amateur television on what we're going to talk about. And then we have 1.2 gigahertz, which is kind of just the same story as 900 megahertz. Penetrates a little bit better than 5.8, but the antenna size is kind of large. The antennas are an interesting thing here. So most of us use dipoles and hex beams, and we use our loops for our communication using audio. But with video, they have these things called Cloverleaf antennas, and these are really, really common with the transmitters that they sell now. It's a Cloverleaf antenna. The radiation pattern is sort of a omnidirectional. It's like a donut, but a little bit more substantial. So it's not like a dipole where it's like just a straight donut. So these actually are fairly omnidirectional, and they transmit up and down pretty well too, which is pretty crucial for what they're used for a lot of the time, which is on radio control models. Amateur television has almost been completely taken over by people using them for RC model vehicles, mostly because that's the only real way to get live video from them. If you try and use there just aren't really any good video streaming solutions that go direct nowadays. And so they use these, and they actually started out a long time ago. Some of the first people it was like, there was a certain guy, I can't remember his name, but there was a guy who actually had the idea to put a real TV transmitter in a radio control plane, and it was a big plane too. It was a homemade radio control airplane, and he put a TV camera in there and a TV transmitter, and he was operating on the 70 centimeter band, and he had a little dipole on the side, and he picked it up with the TV receiver and a TV antenna. And since then, it's taken off quite a bit, and that's why we have some of these more specialized antennas for these applications. So with a model that's moving around a lot, especially like a quadcopter or an airplane, you need a really good omnidirectional pattern, because you don't want to be tilting the model and then going out of the radiation pattern, because that'd be pretty bad. If we look here, we have the 5.8 gigahertz Cloverleaf omnidirectional, and these are the smallest ones, and these are also the most common ones. They're great because you can put a little plastic shell over them, and they're small enough that they can go on quadcopters and boats and cars and planes and not weigh the craft down and not get damaged when there's an accident, because they're relatively small and can be encased in a shell. Sometimes they come without any shell. All these in the picture here, I didn't put a shell on them, so you can actually see what the elements look like. But the 5.8 gigahertz with a little SMA connector on there are the most common ones. And then we have the 2.4 gigahertz Cloverleafs, and those are bigger. So now you can start to kind of see the size here. The 5.8s are about an inch across. I actually have one here. This is one that's got a cover on it, and they're about an inch, maybe an inch and a half across. And it's like a little dome. So there's the Cloverleaf is inside of this, and you put this on your little transmitter here. I have a little transmitter module, and it screws in, and then this sits on top of your drone or your plane. But that's a 5.8 gigahertz antenna. So now when we go to 2.4 gigahertz, they get a lot bigger, And these are less common because of the size, and everyone wants super small. They don't really pay much attention to being able to transmit through stuff. So these are pretty uncommon, but that's what they look like. They're just the same, but bigger. And then we have the 900 megahertz cloverleafs, and those are actually quite big. If I don't know, they're probably wider than this phone here. They're quite large, and they're also very easy to break. These things are. So if you bend these, when they come from the factory, they're set, you know, they're tuned. If you start bending these and warping them, they go out of tune pretty quick, and they can start degrading performance quite badly, especially the 5.8 gigahertz ones. If you bend the little elements on there, it's going to really hurt your performance just because the tolerances are so low with those high frequencies. 900 megahertz is not as bad, but it's still pretty high of a frequency. So yeah, don't break your antenna. These ones I showed you are the most common kind that most people use, but there are some others. There's the patch antenna. This is a 5.8 gigahertz patch antenna, and these are directional. So a lot of people, when they're running their receivers, will actually have two receivers with two antennas that feed into the same display, and it'll switch between them to figure out which signal is strongest, and it'll switch between them. So oftentimes a person will have one directional and one omni. That way, if they're flying a model around and they want to fly long distance, they can point the directional at it and go a long way. But if they're just flying locally around them, the omni will take care of it. So we have the patch antenna. That one's the most common. A lot of cheap receivers will come with a patch antenna, or they'll just come with a dipole. But a lot of them come with the patch. I guess they just think the patch is, you know, a cheap way to do it. It's just like a flat piece of metal, pretty much. We also have the helical directional, which is an interesting one. It's a coil. It's kind of like a spring almost that goes up, and it has to be held in place by something, because if that moves, if it gets out of tune, then it's not even going to be directional anymore. These are very, very sensitive antennas to a lot of things. So they're not, you know, able to be abused at all. You got to be very careful. And then there's a new kind of antenna that's sort of come out recently. It's a sort of new style. That's the pagoda antenna, and it's kind of an interesting design. I haven't seen any ham antennas like this, any lower band antennas. It's like two discs stacked up with a third underneath, and it's another omnidirectional. I do believe it radiates up and down as well as it does on the sides. So it's an interesting design, and it's definitely going to be a lot more resilient to impacts because it's literally just two discs stacked up. So there's not really much to bend or break off tune there. The transmitters and receivers are actually pretty interesting. So used to, you had the big old TV boxes, and actually some back when they had the camcorders that had the little module on them that could transmit the video, you would have a box that would sit next to the TV and receive this, and it was usually a pretty large box. Now these things, especially for the higher frequencies, have shrunk down so small. I got one right here. It's tiny. That's the transmitter right there. This is a 600, I believe it is. Yeah, it's a 600 milliwatt transmitter for 5.8 gigahertz. And the price of these things is extremely low too. These little modules here, these little cheap transmitters, they cost about $10 on Amazon. So you can get a pack of like 20 of these for almost nothing at all. And it's good too, because sometimes you break them, sometimes you overheat them. They do get quite hot when they're on. If they're not cooled properly, they can fry themselves. The connectors on them are not always the best, and they're easy to break off. So it's good that they're cheap, but it is interesting how this technology, this video transmission, has gone from being a pretty rare thing. It was used by television studios and stuff to get wireless coverage for their what do you call it, in the field cameras. Now they're these little tiny baby size things. So I'm really glad that technology is coming to its own, because these are not, widely used pieces of equipment. They're mostly used among hobbyists, and the fact that they've gotten so cheap and so small is really good. But on the left here, you can see what a typical one looks like. Some of them have a screen on them to tell you the channel they're tuned to, and that's the little dipole that they come with, the little black one. A lot of these come with the dipole, and you can use the dipole. That's no problem. But if you're on a flying platform, then you definitely want to get an omnidirectional, a Cloverleaf or Pagoda or something like that. And they just have a little power lead. A lot of these run off of a very wide voltage range, because a lot of models will have a LiPo battery in them. And so these often will support 2 or 3 different kinds of LiPo batteries. Most of these can go down to about 5 volts and go up to, I don't know, 24 volts. Mine right here can go down to 7 and up to 24 volts. So you can power it anywhere in that range, which means you can use a 2-cell lithium polymer battery to power this, or a 3-cell, or even a 4-cell. So it's pretty good, because then you don't have to put a voltage regulator on your craft. You know, that's one less thing you have to do. So it helps a lot. And that goes the same for the cameras. This over here on the right is a typical camera. This is a run cam. Run cam makes a lot of really good cameras. And that's what a typical one looks like. It's just a little module. It's about the same size as the transmitter. They actually make them really, really small now. I have one on my radio controlled truck that's probably about as big as my thumb. I mean, it's tiny, but the image quality is fantastic. So they make them like that. They've got a little connector on the back. These also generate heat. So if it gets too hot, don't use hot glue. If you're making a model, don't use hot glue on these, because the heat that they generate will melt the hot glue and it'll come off. I've tried hot gluing on my first camera and transmitter, and yeah, I learned not to do that pretty quick, because the hot glue got all pliable every single time you turn it on. So that's not good to do that. For their transmitters and receivers, besides the one I showed you, this is another one. These are actually receivers, sorry. They make them built into goggles. And on the right here, you can see a typical set of FPV goggles. They call them FPV goggles because they are used for the first-person view. Most of these people using amateur television on their models are doing it for the first-person view, which they basically put the camera in a spot where the pilot of the vehicle would be sitting. So when they go and put the goggles on, it's kind of like you're sitting in the pilot seat of your radio control model. So a lot of these are actually really cool. They'll have 2 receivers built in, and they'll have 4 antenna ports on them, so you can stick 2 omnidirectionals and a a directional, or you could, if you want to put a patch antenna on there, you can put a lot of antennas on these, and it'll switch between them to figure out which one is best. And the screens inside of these are actually sometimes pretty impressive. Some of them have OLED screens, high definition and everything, and they've got the lenses in there. So when you put these on, you get basically in your field of view, it looks like a very large square with the video being played on it. It's almost like sitting in a movie theater. And they have a little battery pack on them. Some of them actually don't have a battery pack and you have to power them externally, but a lot of them actually come with battery packs now. And some of these can also output to a standard RCA cable. So if you want to hook this up to a television set and show your friends, that works too. And then they often have a DVR built in, which is actually something that you don't see often on the cheaper goggles. You usually only see these on the more expensive ones, but you can actually put an SD card in there and record your footage. And that's very important, because if you're flying a model, especially an airplane or a quadcopter, and you lose your control signal or something breaks and you're a long way off, that recording of the last scene thing before it goes down too low and you lose signal, if it's going to crash, that recording could be what it takes to actually recover the model. You can see where it was facing when you lost reception. If you just don't have a DVR, then you kind of just have to go off memory. But having a DVR for a long range mission or something like that is very important. And on the left here, we just have another receiver. These output to specifically USB. So on Android phones, you can actually get an app for these devices, which will display the output over your Android phone screen. I don't like these because the latency is usually pretty high. The latency is an interesting thing about these systems. It's very, very low. There's cameras that are optimized for latency. There's cameras that are optimized for picture quality. But the latency is very good. And that's why a lot of this hasn't been switched to any kind of digital system. There are digital systems that have sort of started popping up recently that are very good. But people who are professional quadcopter pilots who need very, very quick reaction timing, they'll swear by the analog system, because there's just almost no latency. It's like maybe 15 or so milliseconds. I mean, it's minimal. But when you plug this into an Android phone, the latency becomes very noticeable. And some of these little standalone units actually put out over RCA cable as well, which is pretty nice for plugging into a TV. Although often you have to use an HDMI converter because some TVs don't have an AV plug, or it's just more convenient. This is another transmitter and receiver. This is a 900 megahertz unit. So these units, this in the picture here, are actually sold a lot with security cameras. And I'm not really sure why someone would want to use this for a security camera. If you're getting power out to the camera, and you don't want to run a video cable, that's understandable. But you are also now broadcasting your live feed over the airwaves, and these may not be 100% legal, especially to do with that, because this is on the amateur television frequency. You have to have a ham license to use any of these devices, but they're sold without telling you that. So, I mean, there are thousands and thousands of people using these on their models with no amateur license. They've never been prosecuted for it, and they likely never will, because the range is relatively limited. Even on an aircraft up in the sky, the range is not going to leave your neighborhood. I mean, the signal will not leave the neighborhood. So, detection of this is very difficult. Luckily, I am licensed, so I get to use all this. But when you're doing the, 70 centimeter, 900 megahertz, and even the 5.8 gigahertz, technically, you're supposed to probably broadcast a call sign with it. But not much of this hardware. I haven't seen any hardware that actually gives you any option for identification. You can set up an on-screen display if you have that, and you could put your call sign in the corner of it for identification, and that's about all you can really do. But having a license is usually enough for these. So this is a 900 megahertz unit here, and that's what they look like. They're not very big. They do consume a lot of power, though, especially the 900 megahertz stuff, because that uses a lot of juice, especially when you get like a 1 or 2 watt version. They sell these in different power ranges. So some of these units are like 25 milliwatt. That's a pretty common one. Those are often put on drones and quadcopters and airplanes. But there's also 600 milliwatt, 1 watt, 2 watt. It pretty much only goes up to 2 watt. Any more than that, and you'd start to have problems with heat sinks and power consumption. So I'm going to go through some of the stuff I've done with amateur television and what you could do too, because this is all very, very cheap. You could buy a camera, you could buy a full transmitter set for $15 on Amazon, and you could buy a receiver for $30, and you can plug that receiver into your existing television or computer monitor, and you're good to go. I do a lot of RC models, so this is my truck. This is a Redcat Racing Gen 7. It's a rock crawling truck. It's got 4-wheel drive. It's really cool. And the left picture here, you can see it at the beach. And what I did at the beach was I actually set I put a better antenna on it. You don't see it in the picture here. It's actually got 2 little short antennas on it for the control system. But what I did was I set up a little tower at the beach, and I drove down the beach must have been about a mile, I think. You don't want to go much further than that. In fact, you don't really want to go a mile away from you on the beach, because if someone were to steal this, you'd have a hard time getting it back, because it is kind of just a little toy driving around, and anybody could snatch it. But it is still fun. So on here, I've got a long range module on here, which is actually an upgrade from what this truck comes with. These come with 2.4 gigahertz systems, and the remote controls don't put out very much power. You can get about maybe half a mile if you're lucky with these. Even that's a bit of a stretch. Quarter of a mile on land. So there's a big difference when you go up in the air, but on land you get about a quarter of a mile at the most. With the long range system, you can get about a mile out of it with the setup I have, but I am working on a better setup. On the above the GoPro here, you can see the little dipole antenna. I was just using the dipole because I didn't want to be wasting any output power up or down. I wanted it to be going straight out, because this is a land vehicle. It's not going to be tilting that much. So the transmitter is actually behind the GoPro. You can see the antenna a little bit better here in the picture on the right. But I don't know if I can zoom in on these. Can I zoom in on these? I don't think I can. Sorry about that. The little camera is right here under my cursor. It's the little blue thing, and that's the size of it. It's really, really small, and that puts out a really good picture, and you'll see some footage of that in a minute here. I've actually got some videos of what the system actually puts out. So up on the roof rail, I've got all my equipment. Inside of there is the battery, and this is what the little long-range module looks like here. These are on ham frequencies as well. This is not so much amateur television, but it is amateur radio. You do have to have a license to use these. They do tell you that when you purchase it. And luckily I do, because it operates on 433 megahertz. The transmitter has an output power about 500 milliwatts, but you can upgrade that to whatever you want using a linear amp or getting a different model. This is a little repeater setup. So I've actually built a repeater for this. What it does is it takes the 2.4 gigahertz signal. It's got a little receiver on here for that. and it actually converts it into a PPM signal, which is a pulse position modulation signal. It basically sends all the channels from the transmitter over a single line, which goes into the back of the UHF module. And that is rebroadcast over the UHF module with much more power and a lower frequency, which is picked up by the truck. So it's a little repeater system. I haven't really seen anyone else build one of these, so I guess I'm kind of the first to do that. But I have plans to upgrade it with a better antenna, and I might even build a Yagi antenna to mount to the tripod, so I can point it somewhere, like I can point it up or down the beach, and then I can really get some range out of it, because then it won't be wasting any of the output power. So these little UHF modules too, they also have stuff like head tracking and fail safes in them, which is pretty cool. Fail safes are very important for models. If you lose signal, you don't want the truck to just continue moving. You actually want it to stop. Otherwise, it'll drive into the ocean or something. But that's the little repeater system I have there. This is an overview on the left of the green truck. This is a relatively new truck, but that's the remote on the ground there. On the right, we have a truck that actually made an appearance at last year's Hamfest. I drove this around at the Hamfest, and I've got some footage from that, which is actually kind of funny. It's got a UHF dual band antenna on here for their control system. And then the antenna for the video transmitter is this little mushroom radar dome looking thing right here. So that was actually the video transmitter on there. And this truck was actually pretty cool too. I took this to the Hamfest, drove it around inside, got in a little bit of trouble for it, because I guess they don't want me to, they don't want people tripping over it, which I understand, but it was kind of fun. I also have a little audio transmitter here. The video transmitter was not hooked up to the microphone at the time. I was actually using a separate little wireless mic, and that was giving me audio. So those are two of my main projects I've done with this. This was the truck again, another angle, and here it was at the Hamfest. That was at the Riverside Church that happened. That was the last Hamfest. So there it was, driving around. I have some video to show you guys now. So let me stop my screen share, and I'm going to start it again, pointing at the other thing. And let me read the chat here for a second. Okay. All right. I have some video, and the video on this is actually rather hard to get because you have to have a DVR. And I didn't have a DVR, but I had to borrow my brother's DVR. So the first clip I'm going to show, let me switch the screen share. All right, there we go. The first clip here is what you see from the transmitter. So, I mean, it is just kind of a video from the truck's perspective, but you can kind of see what goes on. There's a little bit of chromatic aberration here, I believe is the word for it. It's where you see sort of like rainbowy pixels. And I've tried to research this phenomena, but I really can't find out much more information on it. It's some kind of distortion caused by the camera. But yeah, so this is pretty cool. This is what I like doing. I will occasionally put the repeater outside, and I'll hook the receiver for the video feed up to my computer monitor, and I'll sit inside and drive this little truck around outside. The little camera's on there. I have tried putting the camera inside the actual little cabin, but these cameras don't look out through windows too well. The plastic tends to get a lot of reflections on it, and it doesn't really work that well. And when you have it inside, these also don't have a really good dynamic range. So you end up getting an extremely washed out, bright picture out the window because it thinks the interior of the truck is dark. So it's got to boost that brightness up. But there's actually a lot of people who do this. They'll put a camera on there and they'll go rock crawling or something. And it's pretty fun. If you want to try that off-road experience, but you don't want to buy a Jeep or something like that, this is one way to do it. I've seen people put a lot of effort into the interiors on their truck with like a little miniature steering wheel that actually moves when you steer and stuff like that. So there's a lot of ground vehicle stuff people do. And when people get really serious with this, they typically go with a 900 megahertz transmitter. And that's when they actually have enough real estate on the model to put that 900 megahertz antenna on, because those are quite big and they can usually sit in the body of the truck and not get damaged. But if they don't have room, they'll probably go with a 1.2 gigahertz system. That's just small enough to fit inside the cab on most model trucks, and it's the lowest option. And you got to have that lower frequency and higher power with these things, because since they're on the ground, there's almost no line of sight unless you're just driving in an open field. These things are fun to drive around houses and things, but without a low frequency control link and a high power transmitter, you're going to lose signal immediately. as soon as you go behind an obstacle with a lower power system, it turns to static instantly. Like you lose it completely. So it's not really great for, like with a handheld, you can transmit, you know, and you'll hear the person through houses and stuff all the way down the street, no problem. But the video signal, that's one thing about amateur television that kind of confuses me, because the signal on it, it doesn't really fade out that much. If it's either there or it's gone. I'm not really sure why that is, but you lose it and it is gone. So this is kind of what it looks like. You can see the clouds and everything look nice. The cameras that they sell you are really good quality cameras, but again, there's an upper limit. The resolution on these things doesn't go past oh man, I can't remember the resolution. I think it's 640 or 680 by 480 or 620 by 480, something like that. There's no 4K video or HD even. It's kind of locked. But the thing is, you don't really notice it when you're actually driving. You don't notice that it's not really blurry. I don't know how to really describe it. It doesn't get blurry. I have some other video here, which is from the Ham Fest. Let me share my screen again for this. So this was back a long time ago, and the setup was just in its infancy then when I started doing this. So this is recorded from an onboard camera. You can actually see in the bottom corner here the amateur television camera. This was recorded from, this is the same thing I was seeing. You're not going to see the static or noise, but there's the trailer. There's me setting it up. There's the entrance. The guys are pointing at it. I went inside, all right, and they didn't take too kindly that. You can see John sitting there on the bench. And I had my call sign printed on the front, so they knew who to find if they didn't like it. But I took it inside the main room, all right, and I was driving around. I was being careful. I could see, you know, if there was someone in front of me. I had a nice clear picture, and I didn't go too close to anybody, but it is kind of fun driving these things. It's like driving a little miniature car. It is driving a little miniature car. But yeah, they didn't. I drove around over here, and then somebody ambushed me and was like, "Nope, get out." Some people were waving at it. It was pretty fun. It was a fun little thing. But hold on, let me find the clip where they told me to leave. Yeah, it was after I drove under a table. Maybe it was then that they realized, hey, somebody could trip over this. No way, it was Tom Mealy who told. Oh, it was him. He's the one who's. Oh my goodness. I didn't even remember that.
He's
the one who kicked me out. They might have let me stay in. See, I was worried I wasn't going to be able to get around these guys, but I did. It was Tom who kicked me out. I can't believe this. He does not like fun, I guess. But there you go. And see, the whole time I'm sitting out here on the little porch area. And it's just really fun. It's a fun hobby to do with the little remote pilot there. You see, I had a little repeater sitting on a stand there. And yeah, I came out here. I drove around some more. I did end up losing signal at one point because I went on the other side of the building. Yeah, here I am going on the other side of the building. That wasn't a good idea. There's the satellite tracker there just kind of sitting there. I drove, yeah, so I started saying, okay, I'm going to test my range out. And the thing is, every single time I've driven this, I have lost control signal before the video signal. The video signal usually outlasts the control signal, even though the video signal is operating at the same power level at a higher frequency. So you'd think, yeah, see, here's why I lost it. It was just stuck. So I had to actually move the repeater to get my signal back. But every time the video signal outlasts the control signal, and I just think that's really strange because it's the same power output, higher frequency. You'd think it would have more problems than less, but I don't know. Maybe I don't have a good antenna on there. So that's that. That's the vehicle stuff. Let me go back to sharing the screen of the presentation here. There we go. Okay. So that's the video for that. The other thing I do with this is radio control airplanes. These are a lot of fun. I haven't done a whole lot with this. I've done a lot more with the trucks and cars than I have with airplanes, mostly because when you crash these things, it's terrible. You spend all this time working on it. You painted it nice. You made this lovely plane. You fly it a few times, then you crash it and it's just shredded. So I don't like that too much. This plane here in the picture is it's a trainer airplane. So it actually flies really, really good. It'll sort of self-level on its own and just kind of coast through the air. It's got plenty of power. I've got an upgraded motor on there. it is fun to fly. I haven't flown it in a while. I should get back out there and fly it more, just so I don't, waste this nice plane I have. The interesting, these foam planes actually don't cost that much. It costs about $100 total to actually build the plane. I ordered this as a kit from a company called Flight Test. They make designs and they actually sell foam kits. So I bought the foam kit, and then I also bought electronics to put in there. It's got a speed controller and a receiver and a motor. And this plane operates on 2.4 gigs for the control link, which is fine because it's line of sight and you don't really want to fly it that much further. Though in this case, the control signal will last fine. But if you put a camera on there, then you're going to want to make sure that you have plenty of coverage. A lot of remote controls will give you a sort of beep or alarm to let you know you're running low on signal, which is good because a lot of the receivers that people use with these planes are goggles. So you can't really look down and see your signal level. And so that's one of the reasons I've crashed a couple of these planes that I've had. I had another plane before this, and I crashed it a few times, but I think I've crashed this plane once because I lost signal, but luckily I recovered it and there was no damage. So yeah, that's one thing to keep in mind. I have some video for this. It's not video from it's another case of the camera being a separate camera, but that's the only way I could record it at the time. And I really love putting cameras on flying things because it's like you have a bird's eye view of what you're doing. So let me share your script clip here. This is when I put a camera on the foam plane and I actually faced it backwards, which is kind of odd because it's almost a more interesting view than the front facing one because you can see the little fins moving and everything. I've got the aileron and the rudder there going to steer it. This is a 2-channel plane, or sorry, is it a 3-channel? 3-channel plane. So there are no ailerons. You just have rudder and the elevator is how you steer. But I was flying this around here in this open field we found, and yeah, this is kind of what you see. I mean, this is reverse pointing backwards, but it's the same thing facing forwards. Sometimes in the video, this is another thing. Video transmitters, when you connect them up to the battery to get power, the speed controller for the motor will actually sometimes put interference, and you'll see it on the video as artifacts like white lines or like a sort of dotted pattern. Some people actually have it so bad they got to put filters on the DC line to eliminate it, but luckily I don't have too much trouble with that. The only problem was having the propeller in front of the camera. It would give you these black lines because it was a rolling shutter. That's the other thing. These cameras are all rolling shutter. So if you've got a propeller in front of them, you're going to not see a blur. You're going to see lines going across it. And at certain speeds, like at certain RPMs on the motor, the lines will just kind of freeze in place and they can get kind of blocking your view. But yeah, I actually crashed the plane on this flight. So I was flying at line of sight for this and I crashed it. So that's what a crash looks like from the actual plane. I got confused about where I was facing, and so I gave it controls that I shouldn't have, and I ended up crashing it. But that's another fun thing I do with the cameras, and that was using on there I had a Cloverleaf antenna and a 600 milliwatt transmitter and one of those little camera modules. The cameras though actually do have different. So I bought a really cheap camera, and now I realize later buying a nicer camera that it does make a big difference. The cheap cameras are kind of almost blurry, and the dynamic range is a really important thing because if you look at the sun, for example, if you're flying and the sun's out, you could completely wash out the ground and you won't know where the ground is. That's happened to me a couple times and it was really scary because I'm like, okay, am I about to see grass in front of me in a half a second? So let me hold on. Let me go back to screen sharing here. Share that, view present. So yeah, if you gotta have a nicer camera that has a high dynamic range, and then you can also mess with the camera settings because if you lose orientation, it can be disastrous because if you lose orientation, you give it a control like a turn left or turn right, you think you know where you're going, but you're not, and you realize it late, and then you start trying to correct for it. It may be too late at that point. You may be too close to the ground. You may have flown into a tree. I've hit a palm tree before, just smack right straight into the palm tree. But let's see, these foam planes are nice because they don't really get damaged that much from crashing into stuff. But yeah, so the camera quality does make a difference. If you're buying a camera, Runcam makes really good cameras. They're kind of who's known for making good cameras. Foxeer also makes good cameras. Those are the only two brands I know off the top of my head, but you can get some really nice ones. The one on my truck is a really nice one, and the grass looks nice and crisp, because if I put the cheap camera on the truck, the grass, it can be a nightmare trying to drive it with a cheap camera, because the grass will look all washed out, and it's really, really bad when you take it to the beach. These cameras on here that come with these cheap transmitters, they can be so bad that when you take it to a beach, the sand looks like pure white. I've driven that thing with the sand looking like pure white, and I drove into somebody's sandcastle. I've driven into holes too. It wasn't fun. So nice camera with a nice dynamic range, and just good color response and everything is pretty good. And there's lots of guides online. There's people who fly drones out there really, really good, and they can tell you what cameras to buy. So there's plenty of information out there for that. Another application for these little transmitters is mini quadcopters. Me and my brother both have one of these exact little drones here in the picture. This is a happy model. It's a Mobulus 6 is the name of the drone, and it costs about $80. And these things are so much fun. I have mine here in the box. You can fly these inside your house. So the actual drone is this big. This is the drone here. It's about the size of your hand, and it is very, very light. And it has this camera on there, and people fly these around their house like maniacs. They'll be going like 20 miles an hour in their house, flying through chairs and stuff, and just going through obstacles and things. You put little batteries in them. They're about this big, and the flight time on these is pretty short. For one battery, you get about maybe 4 or 5 minutes out of it if you're flying conservatively. If you fly really fast and use lots of power, it'll not last as long. But these things are so much fun. If you're bored one day and you want to try something new, go for one of these. They're cheap and they're really fun. Although you do have to buy a controller. But they make a controller that works with these. It's about $50. That's what I have. It's a FlySky FSi6. It's a great controller. I've used it for so many things. You can buy, controllers that are $500, $1,000, whatever. I've done mine here. This is my remote control. And these, when you get into hobby grade stuff with radio control models, you don't have to, you can have one controller that does everything. So this remote costs $50. I went and upgraded the antennas on it. It comes with these little antennas built into the shell here, but I went and got some SMA connectors. I did a little sort of like a flush. Hey, Dave's got one too. That's awesome.
I used mine on the boat.
Oh, that's awesome. Yeah,
Really?
that's awesome. These are little great remotes. Looks like you have the same one as mine. I've done a long range mod on this. It's got 2 Wi-Fi antennas on there because this is 2.4 gigs, so I can use high gain Wi-Fi antennas. And these actually will direct your power along the horizon instead of doing what the stock antennas do. It's not so great for airplanes because you kind of lose the more omnidirectional radiation pattern that it had before. But if you point one antenna flat and one antenna up, it does the same thing. So that's my remote. But this it's compatible with the truck, the repeater, the plane, the boat. I have a boat too that I actually modified to have. It was like a cheap Walmart boat. It cost like $30. But I went and put hobby grade parts in it, and now it's a bit faster and it can work with this remote. So I say all that to say you have to buy a remote, and you can buy that remote that I have there. It's $50 on Amazon, and it's a fantastic remote. There's plenty of support online. You can even put custom firmware in there, but it works with this little drone. So for the total package, it's like maybe $150 or so for one of these, and they are so much fun, especially if you start flying them fast. They are so much fun. They're small. They can fit through stuff. They're great little toys. But we actually have some video footage here of what it looks like to be flying one of these. And I think y'all will like this because it is super cool. Let me pull it up here. This is my brother flying it. He's flying out in the backyard. And if you notice cuts, I've cut the video and edited a little bit just to kind of not make it point right at our house. But you can see the antenna. That's my beam antenna. He was sitting on the porch swing. There's my antenna right there above. He's kind of pointing at my bedroom here, but that's my antenna. I've actually crashed into my antenna once with the drone. But this drone actually has an on-screen display. So this is where you could put in your call sign. You see where it says Mobula 6? You could change that to say KM4OBZ or whatever your call is, and then you kind of be in compliance. But here he flew into the swing set. No damage. These things are so small and light that I've flown at full speed straight into a wood slab and it was not broken. So when you're flying these, this is what it looks like. You got a pretty wide field of view. You can turn on stuff like an artificial horizon. You can turn on the compass, and then it gives you lots of information. Like you can even turn on like it tells you how many watts you're pulling, how many G's you're pulling, how many milliamps you've used so far, battery voltage, time flying, signal strength. It gives you a lot of information on the on-screen display. But they're fun to fly. I didn't put any interior flying video on here just because it's kind of a public thing. But yeah, you can fly these for about 4 minutes, and then you just fly it, land it in your hand, slap a new battery, and you can pull the battery out and put a new battery in like 5 seconds. It's really quick, but they're so much fun.
The Hamfest, Tom would be apoplectic.
When I go to the Hamfest, I should bring one of these and just fly it around. I should hide somewhere. They won't know who's flying this thing. So yeah, these are a lot of fun.
And fly it just high enough that he can't reach it.
He's gonna get like a little tennis racket or something and chase it around. People fly these inside grocery stores sometime, and the staff starts chasing it. Well, the funny thing is, you can fly it. You could stand out in the parking lot and fly this. You know, if you have a good antenna system, it's a bit more difficult to do because these are the ones that have the really weak transmitters in them. These will have like 25 milliwatt transmitters in them, just because you don't want to use up so much battery when you're flying these, and you usually don't want to fly too far either. So keeping that battery drain down is good, but you kind of sacrifice it with performance. So you couldn't really fly inside the building from the parking lot, but if you're in the building, then you could have no problem. Sit somewhere in the center of the store, and then you can just fly around above all the shelves. I've seen some video from that. It was pretty funny. But yep, there's your amateur television. It's actually a pretty fun little thing, and it is so people still do ATV for like ham stuff, but it is so rare. I have not ever encountered an amateur television signal. And even online, looking up information about it, you don't really find hardly anything. Some people have actually done contesting with it, I believe.
Oh yeah, there used to be ham TV repeaters up in the Atlanta area, but I don't know if there are anymore.
See, that's really cool. You could set up a camera and start doing your. I mean, it would be like a one-way transmission. You wouldn't be able to talk to anybody, but it would. It would be cool.
You take turns, just like you talk on a repeater.
Just like on a repeater. Yeah.
Oh, you can flip your transmitter on and off, and then you got to. Yeah. That's interesting.
You talk and you watch, and the next guy talks and he watches, and
that's really cool.
That's how it works.
I heard some discussion about an ATV repeater down in Miami, but I think they took it down, or it was only up for a short time.
One in Marietta too, but I don't know if he still has it there.
I'm guessing they're probably fading out.
Yeah,
a lot of guys send QSL cards that are, that's their, they broadcast their QSL card.
That's cool.
And then there's a lot of it's coming off the space station.
Yeah.
Oh, are they still doing
Yeah,
you mean like fast scan TV?
Marietta that would transmit the NASA TV on ham TV.
Oh, that's really cool.
Yeah,
but no, as the space station's going over, they have like a QSL card that's a still picture, but they're sending it, and they'll go through 5 or 6 of them, and you can get 2 or 3 or 4 of them in a pass, depending on how long the pass is that goes over you.
That's like fast scan TV, or is that slow scan TV?
No, it's fast scan.
Wow, man, I wish they'd use it to just put up like a camera pointing out the window or something. I'd rather get that than a QSL card. That'd be really cool. Just have the camera pointing straight down at the Earth, so as it's flying over, you see what you're getting. I wish they'd do that. That'd be so cool. All right, let me see what else we have on here on the good old slideshow.
You don't have any bigger drones, do you? You just got that small one.
So I do. I have I don't have like a really huge one, but I have another one that's about this big, I guess, about the size of a keyboard in terms of width. And that one I got a long time ago for Christmas, and it had like this this Wi-Fi. So a lot of drones will say FPV, or they'll say that, yeah, they'll say FPV. If you're looking for these transmitters, you can searching FPV, Foxtrot Papa Victor, will get you the results for this hardware. A lot of them will advertise FPV on like a drone, but it's actually just sending out a Wi-Fi signal that you use an app on your phone to connect to. And those usually perform really, really poorly. The video feed will be choppy, it'll be delayed, and it will be extremely just like you can't, like, you're supposed to fly it around your house with that thing. And then the field of view on the camera they give you is so narrow, it's just really useless. So any drone I've had that's had that system in it, I've always slapped a all-in-one. I should have brought a picture up here of a an all-in-one camera, but they make these and they're also only about 15 bucks. Here we go. Let me share my screen again. These little cameras here, I have a couple of these similar to this. It's an all-in-one camera, so the camera board and the transmitter are in the same little thing, and this thing is like the size of my thumb. I mean, these are teeny weeny. These make really good spy cameras. You can stick these if you put a little like 1-cell LiPo battery on there, just one of these little tiny things. It'll power it for like an hour, and it's like it's super small, and they have the small antenna, and you can hide these and things. But these are what I tend to stick on drones that are small. So I had a long time ago, I actually so I had this really nice it was a Cyma drone. It was this little green drone. It was probably my favorite little Walmart drone I've ever got. It was really quiet, so you could fly it indoors pretty well. These little hobby grade ones, the ones I was just talking about, are really, really quiet too compared to some of the other stuff you can buy at Walmart. But I had one of those, and it had the Wi-Fi system in it, and it didn't work very well at all. The drone was nice, but the feed was terrible. So I stuck one of these on the top, and I stuck a little battery there with it, and I lost the drone because I didn't realize how far I was from the house, and I realized that the wind was carrying me away because these toy grade drones, they have like a limiter in them, so they won't bank or they won't tilt more than a certain amount, which means you're very limited in the speed you can go. So the wind was actually faster than the drone. One of these little hobby grade ones, I can kick it into manual and I can go 50 miles an hour with these if I need to, and to get rid of that wind. But these cannot. So basically, I got caught in wind and it blew it over the forest. And thinking back now, I could have saved it if I just looked at a landing spot and landed it and went and got it. I could have probably saved it. But at the time, I just kind of panicked, flew, just like was looking around all over the place, trying to figure out how to get it back. And then I'm not sure where it went down. It could have gone down in the neighbor's yard, or it could have gone down in the middle of the forest. I'm not sure, but I had one of these very similar cameras sitting on top, and that's why I tend to stick on little drones like that. So yeah, I've got the big drone, and I've put one of these on there, and then I've got that small drone that I lost. I have another drone, which actually it has a video transmitter on it, but I wouldn't call it amateur TV. It does operate in the amateur TV band. It's on 5.8 gigahertz, but it's a digital transmission that can only be received using the remote control and your phone. The DJI Spark is the drone I have. Let me see if I can find it here. DJI Spark. It's a real, here we go. This is what I have. The drone itself is not super large. It's, you know, about the size of a watermelon, maybe small watermelon. But it's a really, really good drone. So that camera on there is actually an HD camera. It's a nice camera. And it broadcasts the video signal back to the remote control, which plugs into your phone over a USB cable, which sends you the video feed. And that's why it's actually usable. It has a Wi-Fi transmitter in it, but it's got the same problem as all the other drones that use Wi-Fi for their FPV signal. And it's not got good range, and there's latency, and it's just kind of a crappy experience. But this one uses a digital system that I'm guessing is proprietary by DJI. And it actually has a pretty good range. It can switch between 2.4 and 5 gigahertz. And I've flown this a couple miles away. I fly it to the mailbox sometimes because we got mailboxes in our neighborhood, not at our house. So sometimes I go fly and see if the mail lady is there, and it'll go really far. And it's just a great drone. But that's the drones that I have. And this drone is cool too. It's got like vision sensors on the bottom and it's got GPS. So when it's hovering in the air, if there's a breeze, it won't get blown away by the breeze. It'll just stay in the same spot because the GPS will track it and make sure it's not moving. Really, really good drone. Highly recommend. But that's kind of the limit. I have not stuck a an analog transmitter on here just because it'll interfere with the remote signal. And the actual feed that it gives you is really good. It's very low latency, high quality. You can pan the camera up and down. It's gimbal stabilized. I should actually pull up some footage of me flying with this because it's really, really cool. But it's stabilized and everything. So the wind blows, you can sometimes see the propellers coming down in the field of view, but it's not at all like an analog system. I do have some video here. Let's see if I can pull this up. Here we go. This is cool, I guess. This is going to be flying over an area that's actually different, so it's okay that I show it here. This is kind of what you see. Right now it's tilted because I was in sport mode, flying really fast. When you put it in sport mode, it disables the horizontal stability on the camera. I'm not sure why they decided to do that. It keeps the forward stability, but the backward stability is gone, so I don't know, but I've taken this thing up incredibly high. And you can see how stable it is too. Like it is not moving. It's like having a studio camera up in the air. It's our, this is a neighborhood that's a little bit of a ways from us, flying over. The range is so good. I can fly like 2 neighborhoods over with this thing and still keep this nice smooth signal. So it's a really cool toy. You can put it in sport mode. You can go about 30 miles an hour as the top speed, which is pretty quick. Or you can keep it in normal mode and it'll just kind of go along at about 6 miles an hour. It does have a vision sensor on the front, so if you try to fly straight into a house or something, it'll stop you. It's like those things they have on cars now where it'll beep at you if you're about to hit somebody. So it's got some obstacle avoidance. But my favorite feature on this thing is return to home. If you lose signal or the battery gets low and you're not piloting it back, it will actually fly back to the position it took off from and land. So that has saved me multiple times because sometimes the cable, I used to have a broken cable on here connecting the phone to the remote, and that cable broke, but the drone was in the air and the remote wouldn't pilot it back and I couldn't see where it was. So I didn't know where to pilot it back because I had it about a mile away from me. But luckily, all I did was turn off the remote and it actually flew back to me and landed right in front of me. So that was really, really nice. And some people have experienced problems with that, like the GPS taking the drone to China or something. But I haven't had that problem. And as long as you calibrate the compass on these, that hopefully won't happen to you. But it can happen. So I always try and whenever you travel a long distance with it, like if you go to a different state or something, calibrate the compass then, because if you don't, you might lose it. Although I have failed to calibrate the compass a couple times and I didn't lose it. So I don't know. And this drone is cool. You can fly it indoors. I was actually going to fly it for the FMARC for field day. Steve asked me if I would fly a drone for him to take video footage. Oh yeah, I can show my winter field day picture out. Sorry, I said field day. I meant Hamfest. The Hamfest was going to happen, and they wanted me to get footage for the Hamfest, but I was told I couldn't because they don't allow drones at the school. So that didn't get to happen, unfortunately. But you know, it's okay. Let me see if I can find my where is it? Where's my, oh, you know where? I think I know where it is. 2021 field day. Here we go. I found it. And this drone takes pictures too. Let me try and share my screen instead of just a single application. All right. This was a picture I took of the field day location with the drone. You can see the whole area there. And the drone worked great for all this. I didn't have any trouble out of it. That's just kind of a sample of what you can get with this.
We can see about 200 pictures.
Oh, did it not?
Itty bitty, teeny tiny little pictures too.
Oh, you know what? It's still trying to. I didn't share my screen. I shared.
Your library.
I shared the window. Yeah.
Yeah.
Sorry.
Yeah.
Here we go.
Something else.
Oh, there we go.
There you go.
that was the entire field day. You could see the people's antennas out there. I believe that was John's antenna out there. He had with the caution tape around it. And then there's the directional from the club. Over here was, what's his name? N8GU, is that his call? N3GU?
That sounds familiar. N8GU,
I think it's N8GU. I can't remember his name. I think it's Bob or something like that. He's the guy who's going to be running POTA for us, I think.
Yeah.
But he had his hex beam set up over here. I flew from the front of here all the way out. I just flew backwards. And that was pretty cool. I have the video from it. It's just I have to find the video. And I don't know where it is. Did I find it? I guess it's not in this folder. But yeah, the drone is really cool. And it's kind of technically. They don't tell you have to have a ham license for it. This is interesting. They don't tell you have to have a ham license when you buy this. They tell you a lot of stuff about drone safety and everything, and regulations, but they don't tell you you're supposed to have a ham license. So I wonder if that means that the signal is licensed some other way with the FCC. It must be. I don't know why.
You know what bands it operates on?
Yeah, it operates on 5.8 gigahertz and 2.4 gigahertz.
Well, that's because it's in the Wi-Fi
Yeah,
stuff.
it may be under Part 15 or something like that.
Yep.
It might be, yeah. I guess, are there different portions of the 5.8 gig band that are ham and then there's Wi-Fi, like two separate, or are they all kind of the same? Just sort of like a.
I think it's shared.
It might be like 4 through 3 megahertz, because like little like IoT devices can use that without a license.
Yeah.
See, why can your garage door opener use 4 through 3 megahertz with no license, but then if you want to use a RC transmitter, you have to have a license, even though it's on the same band.
It transmits with more power, would be my guess.
Yeah, it does. That's probably why. That's interesting.
Garage door opener doesn't put out that much power. Have that much range, like 150, 300 feet, something like that.
Yeah, it's very limited. So that, yeah, I think you're probably right. That's probably they don't require a license. So there you go. That's the amateur TV ham stuff. And I've been doing this a long time. When I first started, I didn't know you were supposed to have a ham license. Luckily, I got my ham license before I started doing all this. Otherwise, I would have been violating the rules. But a lot of people do this with no license, and they haven't been bugged yet. So I don't think the FCC monitors for pirate radio at 5.8 gigahertz. So this is kind of the end of the net now. Before I open it up to just the rag chew, I'm going to go through the last little bit here. We have a newsletter. We cover a lot of stuff on there. Well, Ian does. He writes the email. There's there's space weather on there. So if there's like a solar flare coming, you'll know about it. There is ham radio news. So anything happened in the world, amateur radio. Oh, the FCC took away another frequency. You'll know about that. Propagation, space weather. So yeah, like geomagnetic storms and stuff like that. Normal weather. Whenever it's hurricane season, he'll put on there the tracks of the latest hurricanes and the latest models. Hamfest updates, just local events, they're put on there. And of course, stuff going on with the tech team. Tech team is a new club we are starting. We've got a bunch of people in here already. In fact, we got a lot actually recently. And there's actually a lot of people now on the email list. But there's no advert. That's the other thing. You can unsubscribe anytime and it will be unsubscribed. We don't have any ads on there or anything. We get about 1 email a week. Ian says that, we like to do more, but in reality, it's probably about 1 to 2 emails a week, if that. So it's not going to spam your box. And there's a lot of information on there. Even though I'm like more in the know with everything and I pay attention to a lot of the stuff that goes on, I'm still excited to get that email because it often has a lot of really good stuff in there. Ian does a really good job with it, and I highly recommend it. Join today the Southwest Florida Tech Team. So we are recruiting folks that want to become active in ham radio. A lot of the clubs do not do so much active stuff. And I'm talking about like in-person or just events being held that are actually physical things where you do stuff. So like antenna building, one of the things I still want to do is have like a antenna build day where we buy a bunch of supplies at Lowe's and then everybody can come and we will build a certain kind of antenna, and then we can put the antenna on the analyzer and see who done it best or something like that, or just kind of show people how to build a certain kind of antenna. You know, we're trying to set up a satellite. We keep talking about this too. I want to apologize. We keep talking about setting up this satellite system. We've been talking about it for months now, and we have it like halfway done, but it's still not up yet. I would have thought we've had it up by now, but we just kind of been moving slowly with it because it's rather difficult to get signals from satellites in space. But what I mean by that is in relation to this is that it would be cool to have a day where we go and we build a satellite antenna or something like that. And everybody could come and we would have the supplies there and you could come and make the antenna and take it home with you. I think that'd be cool. That's just an example of some of the ideas I have for things to do that are active. We like active. And then we also do not charge anything for membership. So it's completely free. And there's no requirements except for wanting to be active and wanting to have some fun with ham radio. So you can go to southwestfloridatech.net. That is the main website. That is the TechNet website. There is also the Tech Team website that is very similar to this and is linked in the TechNet website. So either of those will work. I believe the Tech Team website is SWFLteam.net. Although I'm not sure about that. Don't quote me on that. And there's a Join Now button, and you can actually put in your call sign, and we will get an alert that you want to be part of the team. So that's pretty cool, I think. The club repeater, channel 34 on the standard frequency list, the 444-775, 136.5 tone. This repeater is located in the North Fort Myers, sorry, I think it's the North Fort Myers Power Co-op, or it might be the Lee County Power Co-op.
Lee County Electric Co-op.
There you go. Lee County Electric Co-op building. You can look it up on the map. You can see exactly where it is. And this repeater is not that high off the ground, but it has a really good footprint. I'm not sure how they made it work so good, because seeing that it's about maybe 4 stories off the ground, if that, maybe 3.5. I've driven past it. It's got a little set of folded dipoles on a pole. I'm not sure what you call that. Like in the picture on the red antenna here, right where my mouse is. It's exactly that kind of antenna, but it's not very high. But the footprint is amazing. It goes down pretty far south and very far north. And it works great where I'm at. So I monitor this repeater every day, pretty much all day. So if you give me a call on 444.775, almost guaranteed that I'll come back unless something's going on at work and I'm in the office or something. Give me a call on here. Me and Ian will come back to you for sure. So that's the club repeater. Go and check it out. Go hang out with us. We'll be on there. Spread the word about the TechNet. We've got a lot more people lately, and interest has been growing, but we got to do more. If you share the link to the stream or the Zoom link or the email, that's good because it gets a bunch of people there. In fact, we've got a bunch of people from just people sharing to their local club or to their friends about it. We've got a bunch of people from that, a bunch of regular people too. It's been really good. Radio nets. If there's comments or something, you could just remind people, hey, the TechNet is starting tonight. The topic is such and such. Come hang out with us. We do that on the nets whenever we check in, and it's pretty nice because a lot of people pay attention to the radio more than they do online stuff. So saying it on the radio helps a lot. Swap meets, meetings, or socials. We already kind of did that. Telling people around the world. Yeah, if you're on the 40 meters and you're talking to somebody over in Europe, go tell them, hey, get on the Southwest Florida TechNet. And they can watch the Zoom if they want. Any other way you can get the word out. We want to do a bunch of stuff with this club. We have big ambitions and we want to do a lot of things, but we need people to be in the club for that. So promise you won't be disappointed, hopefully. And then on YouTube, do all the standard stuff that you're supposed to do on YouTube. Donate your old equipment to the tech team. Surprisingly, we've got a lot of equipment donated. I was surprised by how much stuff we've gotten from people who didn't need it anymore. If you don't need something, if you want to clear out your shack, get rid of an old radio, we have a number of projects, a lot of projects that we're working on that need hardware like this. And it doesn't have to be fully functional, nice hardware. we can fix it or we can make use of it in its current state for the stuff we want to do. For example, if you have an old radio that's got a broken faceplate, broken knob, the screen doesn't work, or something else like that is broken, we could probably use that for a remote FT8 station. We want to set up an FT8 system where anybody can remote in and operate FT8 if they don't have an antenna, if they live in the HOA or something like that. So it's a really cool idea, and we can wire into the back end of the radio if we need to. We'll set up a Raspberry Pi to interface with the controls on the radio if we have to. So anything that's broken. I think we actually recently got a Kenwood desktop receiver from somebody. If you're here, thank you very much. We're going to probably use that for the SSTV receiver. We're going to have an antenna and a slow scan TV channel where you can actually send an image to the tech team website. So hop on a certain frequency and transmit, and in a minute or two, that picture will show up on the website as like a live picture. So I can't wait to get that working, but we need equipment for that, and I think we finally may have got it. If you have any computers, so we have a lot of online stuff too, like the airplane tracker, the Broadcastify streams, as well as the satellite stuff. Those all take computer hardware. And if you've got any extra machines, like an old one or something that's supposedly broken, we'll take a look at it. I bet we can get it working. Any kind of SDR, usually people don't have those, and I can understand why, because SDRs are cool. Any of that, if you want to donate that, we will gladly accept it. And when you donate something, you get to use all the stuff that we do for projects. So if we set up something that uses hardware that was donated, then anybody who has donated something gets access to it. I mean, everybody gets access to it. I'm not exactly sure what the plan is there for that, but it's like you get VIP or something like that. Antennas, tower cable, coax, connectors, wires, anything you don't need that could be useful, we will use it for sure. We've had a lot of people donating antennas, and like literally every antenna that's been donated is doing something right now. Ian's got a bunch of Ringo Rangers set up, picking up all the local repeaters, scanning the different channels for the police. Actually, that's not been done yet. But there's a lot of cool stuff going on with the antennas that we've been given, and we're very thankful for all the stuff, because if it's extra and we can use it, then that saves it from being destroyed in 30 years whenever your relatives going through your stuff. It's like, what is this? Throw it out. Yeah, so that's about it. The website, the TechNet website, has a lot of really good resources on it. Ian has done a great job with the website. There's so much stuff on there, it's almost kind of cluttered. We got all kind of resources: county repeater maps, chirp files, calculators, tools for figuring out where your cell towers are, band plans, SARnet, the SARnet stream is on there, live space station position, just all kinds of ham stuff is on there. I have this page bookmarked in my browser. Anytime I need something like this, I just click over there and I can guarantee it's there. If it's not there, he'll add it. We got lightning maps, wind, weather, hurricane tracks, everything's there. So go check out the website. We got a cool stuff on there, and that's where all the projects are going to go. So when we have the live SSTV thing, it's going on there, and there'll be a tab you can click for live SSTV. So that's where it's going to be. It's going to be on the tech team website and the TechNet website. And the last thing is co-host a TechNet. Me and Ian have been doing this for a while, and to be honest, we're kind of running out of ideas. Huge thanks to Lee tonight for coming with a really good topic and doing such a good job with it. That helped a lot, because Ian's been out of town. We've been low on ideas already, and we desperately needed someone to come help us. So thank you, big thanks to Lee for helping out. But if any of you have any cool ideas you want to see done on the net, talk to any of us. We will help you. We will set up the slideshow. Any information you need, we'll get with you. We can get that information. Basically, we'll do everything that it takes to get your idea to come onto the TechNet. And if you want to present something, even better, because you can come on there and give your presentation or whatever you want to do. So please, if you have an idea and you want to help, we are begging for help. We need it really bad. And this is the nets. And Lynn, I hope this is helpful for you, because I know you were asking me about it. These are the local nets going on. We've got a couple slides of these here. I'm going to try and go through these here. The Southwest Florida Traffic Net, 10 a.m. Monday through Saturday on the 685 machine. I'm sure everybody knows where that is. We have the Sunshine Net on the WX4E repeater. That is 8:30 a.m. at every day. It's on this, so it's on different. It's on 2 different repeaters, and it's on WinLink. The 745 and the 975. They're both linked together, and those are the WX4E system. So those 2 repeaters. Tune into any one of those from 8:30. It usually runs pretty late. It usually runs about an hour long. So if you want to get onto that, that's good. There's the Pharmaceutical Net, 9 a.m. all days on the 820 down by the FGCU. And I don't check into that too much. I don't have too much pharmaceutical stuff going on in my life, so I don't really check into that one that much. But it's there if you need it. We got the Loggerhead Net, Sundays at 7:30 p.m. That's actually an interesting one. I have yet to check into. People have been asking me to check into the Loggerhead Net, and I think I still haven't done it, and I feel bad. I should do it. That's on the 146790 repeater, net control WA4WDV, and that's a cool one. I've heard it before. I've listened to it, but I've never checked in. We have the Windmill Net, 9 p.m. Sundays. So you got your Sunday 7:30 net, and then you go on to the Windmill Net. That is on 28.475 upper sideband. Net controller is Charles, KI4GED. Charles is a great guy. He does really good with the Windmill Net and the Gabfest. So definitely go check that one out if you have the capability. 28.475 upper sideband. Then we got the Newbie Net. And this one is between 7:30 and 8 p.m. I guess that means they could start at any time between that.
Yeah, it goes right after the meeting on the AirNet.
Oh, that's right.
That's how that works.
That's right. And then what day is that? It doesn't say the day here. Is that on Monday?
Yeah, it's Monday.
All right. I need to edit this then to make sure we put on there the date. So yeah, Mondays, Newbie Net. It's ran by Larry N1NQU. He's a great guy. He does really good with the Newbie Net, and he does actually help people out. So I know most of y'all are probably not newbies, but if you want to help a newbie, that's a great place to go because they may have a question that you can answer.
And it can also be something at which you're a new. You could have been a ham a long time, but it could be something at which you're a newbie, a particular thing. Like somebody that's been a long time VHF operator wants to get on HF. That's a good place to get some help.
Yeah, absolutely. There's stuff I'm still new at and haven't done yet, and this would be a great place to go because everybody congregates there, and you can ask everyone there, and you'll definitely get an answer. The Lee County Alert Net. I have never checked into this one, I don't think, but that's Wednesday at 7 p.m. on the 165, the old EOC repeater. Now,
actually, that's now on the, I believe that's the Aries Net. They've moved that over to the linked up system.
Oh, they have?
Yep. They did it this last week. I heard it.
Oh, okay. Well, we need to can change that too. We got the CC Flares Information Net happens. It's on the WX4E system as well. And these are the 3 different frequencies, 745, 945, and 865. That 865 repeater has confused me in the past because it's 685. The 2 characters are reversed. Yeah. And that actually confused me recently. I was like, what? The 865? So there's that on Wednesdays at 7:30 p.m. A lot of 7:30 p.m. nets I'm noticing. We got the Buck and a Quarter Net Wednesday at 7:30 p.m. and that's on the new 220 repeater, 224.520. But the thing about this net is that it's sort of you can kind of cheat and you can check into it without being on 220 because the repeater is now linked to the FMARC link system, which we actually need to put information about that on here. It's linked to that system, so you can check in on 2 meter, you can check on them 440, or you can do it on 220. But that's the Buck and a Quarter Net. If you want to go on that, it's entertaining. I've listened to it before. And then you have the Yazoo System Fusion. That's Wednesdays at 8 on the 444, 675, the 750, and the 170, or just put in Fusion Room 21805 and you'll be good to go. Apparently, I've heard good things about this net. Apparently, it's fun. So if you have the means, if you have a Yaesu radio, has Fusion, go ahead, check it out. We have the DMR net, first Thursday, 7 p.m. I'm not sure what local 2 means. I guess that's the repeater. I don't know the frequency. It's not put here. That's the first Thursday of every month, I'm guessing, at 7 p.m. And it's once a month. They don't have many people check in, I don't believe, because there's not a lot of DMR around here. The DMR repeater doesn't have a great footprint, and it's just kind of not that popular. So I guess that's why they only have it once a month. There's the D-Star net, which is a bit more popular. Second, third, and fourth Thursdays at 7 p.m. 443.450. I have listened to this net before, but I have not checked in. We have one D-Star radio in the house. Actually, 2 now. Actually, that reminds me, I need to put this in and actually figure this one out. So there's a D-Star net for you. If you got an ICOM radio that can do D-Star, check it out. Even more nets. We have the Cape Coral Gab Fest. I like this one. I am in a great place that has, for some reason, have a great signal from everybody. Thursdays at 8 p.m. on 146.490 simplex. No offset, no tone. Make sure you know your offset is off, because I had my offset off on one time, and I was like, why can't you guys hear me? Net control is Charles, KF4 GED. He runs the net. He does a really good job. And this is another place that you can kind of ask questions and get knowledgeable people on the radio, because the people on there is usually the same people, and they are very experienced hams. We have the digital practice net. This is another really good one that is kind of not many people know about it. Thursdays at 8 p.m. So this is every Thursday at 8 p.m. They do FL Digi and they do slow scan TV. FL Digi, they send you text over the audio. Michael was actually decoding that the other day, and it was pretty cool. And then slow scan TV, that's my favorite part. I like sending SSTV, and this is a great place to do it. You send your picture, and then you have the people be like, oh yeah, that's so-and-so, or whatever, whoever you sent a picture of. That's Thursdays at 8 at the 820 repeater. Something to note, though, about this 820 repeater. They keep saying there's external interference. There's something up with that repeater. Sometimes your pictures will come out really broken or distorted because the repeater has this awful screechy noise that comes out of it sometimes. And it causes problems for the slow scan TV. FL Digi seems to usually make it through okay, but that's probably just because it's a quicker transmission. Net control is Mark, AC4ZM, as he would say. And he does a really good job. He was helping Micah with it the other day, and he did a good job. He actually guided Micah through the process of setting up FL Digi and getting the correct mode set and everything. And it went great. So that's another really good net that I recommend that more people should go and check into, because it's a great net. And then, of course, the Tech Net, not on the radio. It's on Zoom. Southwest4tech.net. You already know that. Net control is Ian KO4 EFS and Joseph KM4 OVZ. And I believe that is the end of the list. It sure is. Can't even scroll any further. So there we go. That is the TechNet. Now I'm now going to open it up to the RagChew. If anybody wishes to talk about anything, now is the time. It's 10:38. We actually ended pretty late. I wanted to end closer to 10, but this is okay. We had the great presentation.
Talk fast enough then.
I didn't talk fast enough. I thought I was already talking fast enough, man.
All right. Well, let me share my screen, because there was a little something that was in Lee's presentation that he didn't dwell on it. It's a map.
Okay, go right ahead.
All right. So where's the little doolally? I come down there, share screen. I want to share this one. And hold control. Where's the button? Share way over there. Okay, can y'all see the map?
Yep.
Oh yeah.
Okay, so on Lee's presentation, he showed a map. This one here just happens to be using this grid square. Maybe you recognize your own grid square.
Oh, there we go. Yeah. That's
right. Yeah, so that's your grid square. So you know, you can kind of zoom in on this puppy. And what's really cool, if you zoom over here over Africa, you can read the names of these places. And if you had an HF antenna, you would know which bearing to put where's the little duo at the bottom? So I can slide this in. There it goes. You know, you'd know which beam heading to put. I got to get this picture of y'all out of the way. You know, because the Earth is a globe. You can't use that map that's flat. It just doesn't work. And you go to this website right here, and you can put whatever you want to have written at the top of the map. Put in your location, and you tell it how big you want it. If you only want to look at like let's say the continental United States, because you wanted one of these and printed out for 6 meters, and you were only expected to yay so far on 6 meters. There's that map, and now you know which way to aim to get to Texas or Pennsylvania or, you know, wherever. And you can print up a whole bunch of these, and they're cool.
That is
and they're
cool.
free. So
If you make it, if you make the range like 200 miles, do you see city names?
We'll find out.
No. But that bearing thing is still kind of cool.
That's pretty awesome.
Could overlay something on it, or not overlay, but
That could be really useful to me, and I get that hex beam.
Yes. Yeah. So when you got that beam,
what?
you know, you need one of those right next to your rotor.
Here, Micah says you can turn on label cities if you click the checkbox on the generate page.
I don't know. Did you see that?
Let's try again.
There we go, on the right.
Oh, okay.
Yay.
This turns out like it showed up. It didn't switch your tab for you. There we go. Oh wow, look at that. That's really good. Then you know exactly because when I do UHF, I need to know city names.
Direction to Miami.
Thanks for sharing, Dallas.
That's really cool. What is that? NS
NS6T.net.
NS60.net.
NS6T.
Azimuth maps. There we go.
Make it a little bit bigger. I'm thinking that's most probably the maximum range you'd get out of a UHF with a little bit of ducting.
Yeah, that's yeah. That's about it. Although sometimes you can go pretty insane distances with it, even further than this. But yeah, I usually get into Miami.
Okay, so let's back up. Where's the back up button? Okay, let's
Yeah.
okay. This somewhere up in here around Tampa, there's a 146.64 repeater with a PL tone of
146.6.
Over here in Weatherford, Texas, not Weatherford, Texas, Round Rock, Georgetown, Texas, we have a repeater that's on the same frequency and PL tone as one in Tampa. And on our Aries nets, every now and then, one of these bozos from Florida just checks in just because he can. You know, during the summer months, it's twice a month at least we get somebody from over there. They're really nice about us using their repeater frequency. They don't complain.
Get off this frequency.
No. But anyhow, so yeah, so you can just go there, have fun, make a couple of maps, save it as a PDF, and then there you are.
I made me one just right now.
And the PDF, you can zoom in on the PDF, and those things are there.
Yeah, if it's a picture, it might get blurry.
It gets blurry, but it's still there. And, you know, if you kind of halfway know which country you're aiming for, it's there. But, you know, the QRZ does that same thing. You know, if I was to, I don't remember your call. There's your call right there. If I was to put that in and I went to details, you know, it tells me that you're at that bearing and then you're yay so many miles away.
Yeah.
That's got you in Madison, Alabama.
Oh yeah. Does it say that still?
Yep,
Yeah.
there you are.
Yep. Incorrect info. You're gonna be pointing at the PO box.
Well, how did I get your the grid square right? Because I got your grid square right there.
The grid square is correct, and I don't know why, because I never put it in manually. But the address is, if you hit show map, it's accurate. So I think that is
Weird.
Yeah. See, that's pretty good. So
and there's all the hams that are around you.
that's pretty cool.
You know,
I know there's a guy in my neighborhood. I haven't spoken to him yet.
You know, you can click on all these boxes and then you say, wow, there's, you know, in those 6 grid squares, there's 114 hams.
Wow.
You just got to go walk in the neighborhood with your drone and, you know.
You gotta find the antenna. I know there's a guy who actually lives in the neighborhood, one of the neighborhoods around mine. And I talked to him on Simplex when the last hurricane was coming through. When Elsa was coming through, he was on Simplex. That was pretty cool.
Yep. So you just find out who's who in the zoo and drive your little man, drop it on the street, look at their house, no antennas, they're a paper ham.
Paper ham. Actually, I think that's the one who's.
They're a paper ham. They're only on paper. You know, you don't ever hear them. You don't see them at meetings. You don't hear them on the air.
Man, I knock on his door.
There you go.
If you go by my house, you may not see the antennas because they're pretty stealthy. But both of my HF antennas, you might see my X50, which is my VHF UHF antenna, but you probably won't see the HF antennas.
Yeah.
When I get my upside down umbrella, that's going to be a different scenario.
Yep.
How did you get the hams in your area?
Let's see, there's another site that does that too.
All right. So give me your call sign.
AC3AV.
AC3AV.
Yeah.
Yeah, I've looked you up before. There you are. So you go here and then you click on detail and then you show map. And then you click on this thing and it does not look like a link. You click on that and then this lets you select all the grid squares around you and find out, you know, how many you got.
That's really cool. I know there's that other website that does it, but I didn't realize this was built
Yeah, but
into.
see, QRZ's been doing it for 15 years, but no one knows about it because I didn't tell everybody about it. That's why I'm telling everybody about it. And I've used it because, you know, when we were in Austin, we had the chance to put a repeater on a water tower, and they had like 6 or 7 water towers in the county. And they were basically telling us, we get to pick. And it's like, okay, you got all these people over here and you go over here and it's like, wow, we're going to use this water tower right here, okay? No, we're not going to put a repeater out on this water tower because there's one ham over here. There's none in that zone. Oh, there's none over here. There's 3. No, let's put it over here where there's lots of hams.
Yeah.
You know.
It's interesting. It won't do it on my Mac. I'm using Safari as a browser. I can't get the additional info.
You need to upgrade to a real computer.
I just did. How many cores have you got in yours?
How many cores in this thing here? It says this thing here is an Intel i3. It's about let's see, my daughter's now 32. She got out of high school about 14 years ago. So it's a pretty old piece of crap.
Yeah.
But you know what? It's paid for. And I can unplug it from the power. And look at that. Oh, see how the screen got dark? Maybe it did get dark on y'all end. The battery, if I keep it plugged in, it works fine.
It will not run Windows 11.
Yeah.
It's got Windows 10 on it already. It will
It's,
most likely run Windows 11.
Yeah. Oh, dear.
But anyhow, I wanted to share that map with you because a lot of folks don't know about these azimuthal, I can't say that word, map.
Yeah, it's interesting that map you showed, not the one you got up now, but the one a couple back. I could see Wyoming at the end of the world. So,
Yeah.
you know,
And the one
I'm totally convinced that Wyoming doesn't exist. But, you know, people tell me it does. You know, I don't know anybody who's been there. I can't work anybody there.
when Lee had his, he had like the edge of the world was right around this circle here.
Yeah.
So he was like trying to see all the way around the world and a little bit too much. And at that point, everything is too small. You can't see anything. You want to be able to just see a little bit beyond halfway, and maybe not even that. You know, it depends on what you want. If you want 2 meter 440, this is exactly what you want. If you want one for 6 meters, you might want to see
3,000 miles.
North America and parts of South America.
Yeah.
Okay. I can't close this thing because this stupid little screen thing. I know what I can do. I can do this. There we go. There's things that pop up with Zoom. They pop up right where you can't do what you need to do.
Oh yeah, you get the little pop outside thing.
Your screen's being shared. Stop share. I'm gonna stop share. There you go. Hey, I just learned something about Zoom. There's a button, stop share.
How's your Linux thing been going, Dave?
Okay. It's on a hiatus at the moment because I realized that the computer is actually, I mean, it's a little bit newer than Dallas's, but only just. And it's you know, the screen resolution and everything else, I can't get enough on the screen and whatever. So I'm kind of going to go via the Raspberry Pi thing, but I managed to find a new iMac which is fitting in nicely. So I've kind of been concentrating on at the moment. I've got one of those new power iMacs, which is you know, a pretty wicked device with 64 cores.
Oh, 64.
Yeah. 320 megabytes of RAM.
That's nothing. 320 megabytes.
And at the moment, it's only got 256 megabytes of SS, the solid state device in it. You know, the hard disk.
Oh, 250.
But I run a bunch of external disks because I've actually got my own little cloud. You know, here, yeah. So that's not a problem with 3 terabytes in it. But you know, I got it. It's kind of a new device. I used to work alongside. We used to be Apple developers, so my chain is still hooked into them. So it's their next generation iMac, which came my way for testing, but I'm going to keep it. So.
Oh, okay.
So, yeah, it's the new iMac in the old case. They need the old case to get everything in because they haven't shrunk it down enough yet. but it's a Power Mac. It's a Power iMac. So it's I've been kind of concentrating on that, playing around with that. And I dumped the new Moldova, I think it's called, the new OS, and went back to Big Sur. So I've been playing with that and getting everything going, and I've been playing with these boats. So because it's winter and we the season, I raced the boats in the winter. So the one you can see behind is just about to be torn apart, new sails and stuff like that. And I'm seriously thinking of putting in one of those cameras.
Yeah, you should.
That would be really cool.
Yeah, they're a lot of fun.
Even two, one on top of the mast and one down on the deck.
There you go.
So
and they're so small, you can just stick one on. I mean,
yeah,
they're tiny.
Well, that's quite a big boat as well. It's nearly a meter across. It's quite a long way from the camera on the Mac. So
yeah, wow.
And at the moment on this machine, which is the older Mac, I'm only, if you see zoom at 4K, it's unbelievable. This is only 1080p, because this is my old Mac, but with the new one from up there, when I put that on, it's unreal. I got to clean my office. You can see all the crap.
Oh, the camera's higher quality.
Yeah, a lot higher quality.
You got to have that blur.
Yeah. You got to eliminate. You can see the books.
You can probably read the titles on the books.
Yeah, you can see the thumbprints. So so the PC, it's still sat here, but I realized that you can only squeeze so much out. Basically, it's the screen resolution that's the killer, because FT8, I've got FT8 working fine, and then when I tried to put a grid tracker on it, it's too, occupates too much of the screen. It's overlapped all the time.
Oh, yeah.
So, but I'm going to use it for something else. I think I might use it for, just DX hunting or something like that. Put it up on a stand so I can view DX.
Just treat it like a Raspberry Pi.
Yeah. But what I have been doing, which is absolutely incredible, is I've just had cataracts done on both eyes. So I've been kind of grounded, and the right eye didn't go too well. So I can't drive or anything yet. So I've been playing around on FT8, and I've been doing it on 15 meters because that's the only band I haven't got an antenna for. And my figures are unbelievable. I've got 73 countries and 38 states in just over a week.
Wow.
On
crazy.
15 meters. So, that's what I've been doing.
That's amazing.
So,
and 15, yeah. See, I was hearing good things about 15. Ian was talking about 15 meters.
Yeah,
I think
that's a great band.
Yeah. Well, when conditions are open, I mean, it goes dead as a pancake after, or as flat as a pancake, should I say, after around maybe 7:30. Doesn't come alive until maybe as late as 10 o'clock in the morning, or maybe 8 sometimes. But funny enough, the big squares, not the little squares, but the big squares, the biggest square I've worked the most of is the middle of Europe. I've got way more contacts in Europe than I have in the UK, in the US. And I've worked the whole of the UK, different squares. So, and I've done something that I don't usually do, is I just switch it on and call CQ. So I've left it for everyone else to contact me. I've not been chasing.
That's cool. So, see, that's what I think I want to do more of.
Yeah, I've got Iceland, Greenland. Hang on a second. Let me tell you. Oh, here we go. Yeah, I'm quite surprised. I mean, obviously we've had a couple of good weeks with conditions, but I'll give you some idea. I mean, the band packed up tonight just as we were coming on. Where am I? United States, worldwide. There we go. I'm just doing an Ian and filtering everything. Yeah, I've actually got 50 countries confirmed. on 15 meters. So yeah, I've got a couple in Alaska, a bunch down South Australia. I've got a couple New Zealand. That's all around 100 watts to a 40 meter offset center fed dipole that doesn't resonate that well on that band.
Wow, that's
So,
crazy. It's working so well.
Yeah, so what I'm looking for is, because Lee, I worked with Lee this week. If you want to see Lee's talk again, we're doing it on our club on Wednesday night. He's doing the same talk for us. So I worked with him last week, the beginning part of last week, to you know, clean up the videos and bits and pieces. And he inspired me to go out and you know, get an end-fed antenna, because I live in an HOA, so everything's stealth. Most of it's in my attic, but I think I can squeeze the end-fed outside. And I found a website called, oh God, I have to look, HF Kits. And basically they sell antennas, but you know, and toroids, balums, you name it, in a kit form, and the prices are really good. So, you know, instead of buying all the bits and pieces, I need to make a 49:1 balum or 49:1 transformer, because you need a 49:1, because end-fed is about 2,500 ohms. We obviously need 50. You can buy a kit of all the bits you want, rather than buy, you know,
Does it
half
come
a
with
dozen toroids when you don't need it all.
Does it come with instructions for how to make it?
Yes.
Oh, see, I might
really good, but there's a ton of stuff there. I don't know. Let me see if I can get it for you.
Yeah,
HF
let's see,
kits.
let's write it down.
Yeah, but it's not here in the States. You got to wait for it to get shipped here.
No, they got stuff here.
That's good.
I ordered HF kits. Yeah, they've got two kind of distributors. Believe it or not, one of them is ARRL. It's the kits.
Yeah.
So
Those
you can.
might be the league was selling an end-fed half-wave antenna, and that might well be what it is.
Right.
That
And, and I've heard not good reviews of that one. It's like they give you one core. Now, yes, you can most probably buy a second or third one. But do you have 100-watt radio or one of them 200
No,
watt?
100 watt. I bought the 100-watt kit.
Okay.
You can get it in, and I bought the one. Hang on, let me see if I can find it.
You see, I've got a single toroid antenna, the 40-meter one that I built from Steve Ellington's videos. And next time around, I'm going to do a dual toroid.
Well, these take the Steve Ellington's design. Basically, they're if you look at them, they're almost identical.
Yeah.
You know, same capacitor,
Good
everything.
design.
Yeah. I was going to buy all the parts, and I was looking for the parts, and then this website came up, and I realized, you know, the box, the cable, everything, and it's like $50. You know, so it's cheaper than buying all the bits and pieces separately. I mean, I haven't got it yet. It's coming Monday, but I'll let you know. I'll take pictures and go from there, because you know, I live in an HOA. We're pretty much restricted here, so everything I've got is in my attic. So I think I can run an end-fed, the similar as I run my 80-meter off-center fed dipole, and he says they're better than a dipole. So than the center fed, off-center fed dipole. So I thought, okay, we'll give it a go.
Yeah,
And if
Steve
it
Ellington
works.
made a believer out of me, because he set up an antenna, and he set up, it used the same antenna. He just changed the wiring on it. In one instance, he center fed it on 20 meters, and on the other, he shorted the center of 20 meters and then fed it at the end with a 49:1 transformer. and the signal strength was identical. So there's really not much difference. The advantage of the in-fed half wave is all the different harmonic.
Yeah.
The harmonics can be used, which is wonderful. You don't have to change antennas all the time.
No, well,
that 80 to 40 to 20 and 15 and 10 on this one here. I don't change anything. I just change bands.
yeah. Well, that's one of the things I was interested, because I was thinking if I can put that on FT8, I can just, you know, change bands and we'll see if it works.
Gangbusters with FT8.
Yeah.
I've been doing this with CW and sideband. It works great.
Yeah. My problem here is like one of the guys in the club bought a vertical to go on top of his roof. I can't remember the name of it, but he didn't like it. It was wobbling around too much and everything. I put that up and it receives great, but transmitting is awful. People can't hear me. So I put down more ground planes, and the more ground planes I put down, the better. But I think I'm getting the same problem with most of my antennas being so close to the ground and indoors. I can hear people, but I can't work them.
Yeah.
So
the radials are problematic and verticals are noisy.
Yeah. Yeah, they are. That's well, it's not too bad here. I'm away from a lot of the noise and I've got water on both sides of me. So it's that kind of helps. And I've got some of the radios running into the water. Well, now because the lakes have risen. But when the lakes drop back down, I'll be out in the ground.
If you want to set up a 10-meter antenna, like for, sideband and all that, there would be no reason you couldn't take and make an in-fed halfway for 10 meters. So, I mean, your good old 468 by frequency megahertz works great.
Yeah.
That's all it is.
Well, what I've kind of fallen in love with, because like a lot of HOAs, our HOA doesn't exist after 3 o'clock on a Friday and before 8 o'clock on a Monday. So if you want to do anything, that the HOA won't let you to do, you just do it at weekends. And I've kind of fallen in love with the Dipole hex beam. They've got a fold up hex beam.
Yeah, I've seen that.
Yeah, I haven't seen it live. I've been trying to get some information out of them, i.e. what's the diameter of the pole, et cetera, but they seem to take about 20 minutes to put up. And I was thinking they're only £9, so I could put a little TV rotator on top of a pole, have the pole, swing up against the side of the house, put some offset brackets, that offset it from the gutter, and that may be something I can do. They're black, and so where people can see my house, because I'm at the end of the cul-de-sac and, we've got like a hammerhead and I'm at the end of the hammerhead, but they can see me from the other side where there's a footpath. That will be all silhouetted against all the palm trees. So, it's a lot of, it's a reasonable amount of money. So I'm kind of tempted, but there's no specs yet. They've got them out. They're just started to sell them.
I took a look at the picture of it the other day. It's a little pricey, but it's got your poles and everything needed to set it up.
That's right, and it all folds up.
Yeah, and it folds
I think it's $600.
Yeah, $600.
500.
Which is about what you'll pay for a hex beam, just the beam antenna itself.
Yeah.
I mean, the KIO is around, when you outfit it with all the bands, it's over $700.
Yeah, well, that's got like a big aluminum plate at the bottom and all the rest of it.
That's probably what I'm going to go for. But,
they've designed. Yeah, this Dipole, they've kind of designed it for HOAs.
Yeah.
Semi-portable, but something where you want to put it up and then, take it down. I mean, they have got their own crank tower and stuff, but that again is another $700 and it's really not worth it. I don't think so, but it might be. But I don't think I'll get it until I actually see it. So I'm planning on going up to Orlando to the Hamcation. He says he's going to bring them there. Yeah. So I might say.
I usually wait till I see some reviews, see what other people think.
Yeah, he's had a few on loan to different bloggers, but they're if you're getting something for free, you're not going to say anything bad against it, are you?
Yeah. Yeah, I guess that's something to be said for that.
Yeah. But, you know, I'm planning to see it there, and I might get.
I
I'll
even
get
looked
one.
at some of the homemade hex beams. I mean, some of the guys are building the base plate out of plywood and stuff like that. I mean, it's kind of funny. I just wanted to see what they were doing see if anybody was actually home brewing them. Yeah, there's quite a few of them out there.
Yeah, I'll tell you what, when I lived up in Pennsylvania, a friend of mine made one. And of course, what he used was the snow poles. You know, the poles you put down your drive, you know, the fiberglass poles you put in the ground so you can mark where your drive is.
Yeah.
And you know, I mean, you can buy them. I think they're a couple of bucks a piece from Home Depot. You can't even get them down here. You know, we don't get that much snow, obviously. But those snow poles did a fantastic job. And they're fiberglass. And
Yeah,
I saw
fiberglass. I thought they had, well, you can also get fiberglass coils from Max Gain Systems, MGS4U, and they've got all kinds of sizes.
Yeah. Well, this stuff that Dipole uses is nylon infused something or other.
Really?
Yeah. So
I'm
it's
curious to see how that works.
yeah. Well, they use it for their you know, their Versity and other stuff like that. So he's had it for a couple of years. It's not like it's brand new. He's been working on it for a couple of years. So, but again, I'm kind of loath to buy the first one. You know, get a few out there and see what the mistakes are.
You never buy version 1.0 of anything.
No, but somebody's got to. But you know, that might be the answer here. You know, at least at weekends for some of the things that I like to do. You know, Florida QSO party is one. We're big on that down here.
Convince them it's a clothesline or something. You know.
It's a bit big though, isn't it?
Yeah.
It's big for a clothesline. That's the thing.
Yeah.
And it's got 4 legs rather than 3. I've never seen a 4-legged clothesline, you know, but I guess that's details that people won't look at. But we'll see. And then you can get 6 bands out of those. So, you know.
Yeah, the thing I noticed about the Buddy Hex is that it only weighs 9.6 pounds.
Yeah.
Your usual hex beam weighs 25.
Yeah, it's going to at least double that. Yeah. Yeah, but the thing is, it hasn't got that big metal plate.
Yeah.
At the bottom, and that weighs quite a bit. Even if it's aluminum, you know, there's a couple of pounds there.
Yeah.
And it the stays that are going out are they're shock corded. They're not a solid piece. You know, you've got the shock cord and they push together. Very similar. I don't know if you've seen the Dipole antennas. I've got a Dipole antenna and I've got the vertical that's shock corded, and it really is quite floppy until it pushes together.
Yeah.
So I guess they've, you know, well, I mean, it's designed for portable or putting up, taking apart, and it looks like he's put a lot of research and development into it.
Yeah.
But as you say, and the thing is, it's not going to be up there in the hurricane. It's not going to be up there in the high winds.
That's the
as long
thing
as it doesn't break when you're taking it up and putting it together, you know?
Yeah. Yeah. You're not going to leave it out in a storm.
No.
So.
Yeah. And, you know, I guess by the time you get used to it, you can probably put it up in, you know, less than 20 minutes.
Yeah.
You know, 15 minutes would be about the limit for me. You know, if it takes longer than 15 minutes, it's probably not worth doing. You know, because I don't want to be doing field day every day or every weekend, you know.
Yeah, you could put it up on Friday night and then take it down on Sunday night, and you'd probably be fine.
Yeah, well, I was figuring Monday morning, you know.
Yeah.
Because I was thinking put it up on a Friday afternoon, and then, you know, if there's something special going on, you know, I can put it up during the week. And the thing is that, you know, I live right out on the corner of the development as well. So, you know, unless somebody shops me, goes in and complains, I don't think anyone would really notice. I've left the vertical up, you know, for over a week, a couple of times, and no one said anything.
Yeah.
Because they're pretty lazy. Our management company, you know, they drive around in their golf carts. If they can't see it from a golf cart, it's not there.
Yeah.
So, you know.
I'm glad I don't have to worry about that.
Yeah. Well, I don't have to do all the lawn cutting and all that crap, you know.
Yeah.
So it's, and I've actually, it's quite a challenge. I quite like it. Working here on the radio. I find it quite a challenge working from the attic. So
Yeah.
yeah, and I haven't got all the hassle I used to have with a couple of acres, well, acre and 3/4 I had up in Pennsylvania. You know, I was spending a day and a half a week maintaining the darn place.
Yeah.
I don't have to do any of that. So each to their own.
Yeah.
Anyway, we're hogging this. Back to you, Joseph.
Oh no, y'all are fine. No, y'all are great. I've been sitting here just listening and having a good time.
This conversation.
Yeah. And I'm in the HOA too, got the same problems, but they only come out around once a week, I think, to look for violations, and they announce it before they do. So whenever I get that, I just take down the pole, watch them go past, put the pole back up. They don't know a thing. Actually, I think Miami, it was. The propagation has kind of changed as the season is starting to turn into fall. It used to be the propagation for UHF was pretty substantial and it happened every night. Now it's kind of starting to get to the point where it's a lot more, it comes in and out a lot faster than it used to. It used to, you would have, you know, an hour of full signal and then it might kind of fade out. Now it's like you got it for 30 seconds full scale and another 30 seconds it's completely gone. It's kind of changed. Some nights it doesn't even come in at all. Other nights it comes in okay. Earlier I checked it, it was at like an S7. It was a great signal, and now it's like, now it's barely coming in at all. And in 10 seconds it'll be back up to an S7.
That's kind of like 20 meters did this afternoon. I like to get on this CW net, which is the called the slow speed test. And on Friday afternoons, it runs between 4 and 5 in the afternoon. I was on 20 meters the whole time. And what'll happen is even between characters in Morse, you'll have the QSB, the thing will just, the band will just drop way down low and come back up, this kind of thing. It's crazy.
Yep, that sounds like what's happening.
Does the grey line have any effect on the UHF band?
It does. So when it gets dark, it starts to cool, and it does. Usually at night it gets pretty good. It starts at about 10. It starts to get good. At least it did. Now it's kind of just the same all day, every day.
Yeah, I was wondering as the lights are drawing in, you know, whether that affects. You were saying it wasn't so good or it was coming in earlier, because I'm finding the bands are giving up a little earlier than they used to back in the summer. But you know, this is really the first summer that I've been seriously working on the radio in here. I mean, last year I was kind of constructing everything through the summer. This year, you know, I've been using what I've got with plans to do more work as soon as it cools down. So I just find that the grey line is having a greater effect, even though it's coming in earlier.
Yeah,
I think it's about it. But you know, you're testing conditions. You're not testing anything else. And it's, you know, I mean, a couple of days ago now we had that big CME which seemed to have closed everything down, and then a couple of weeks before that we had a day or two of really high activity. That's when I worked New Zealand. You know, a cracking signal as well, you know, from an indoor antenna, that gives you a buzz.
Yeah, it worked that far. I've been hearing people have been hearing VKs and so on early in the morning.
Yeah. Yeah, my mom-in-law lives with me, and her bedroom's right next door to the shack here, so I can't get on in the mornings.
Oh.
I can listen, but I can't shout into the microphone.
Yeah.
Yeah, it's changed, and not for the better. Now I can't talk to Miami, and it's disappointing too because the beam I can only have up when the weather's good, and now that the rainy season is ending and the weather's good for antennas all the time, now of course is when the propagation gets bad, and I can't use it very much.
All right, folks, I'm out of here.
All right,
Alice, we'll see you.
Yeah, I need to go as well, to be honest. I didn't realise it was
Yep.
quite so late.
Things to do.
Yeah, I enjoy these Friday nights. They're kind of cool.
Yeah.
And, yeah, you might be getting some text from me about that. I'm just going to resheet this boat and everything, but next week when I've finished all that, I might give you a shout about the cameras. That sounds like a great idea.
yeah, sure. I can give you tell you which ones are good to get and
Yeah, good heads up.
information.
Okay, well, I'm going to wish you all good nights, gents. Thanks very much, and be safe.
All right.
All right, see ya.
Bye.
Now we're here with Micah. Micah's still here. Go to bed, Micah. I know you can hear me. Go to bed.
We're down to 17.
Down to 17. What do you mean?
Yeah. I don't know. There might be somebody that's just sitting there and not.
Oh, there's Dave Nick. Go to bed.
No.
Yes. Bad. Okay, my room. Yeah. I don't know. Let's see if it's back. Now it's back to S5. So it's really annoying because it'll act like it's being good, and then you try and have a conversation with somebody, and right in the middle of their transmission, the computer's just gone.
It just drops out. Yeah.
Yeah. It just completely drops out. Man. I need to figure out a way to like get a node down there or something like an all-star node. You know, this radio apparently this 8900, the data cable on the back apparently has push to talk as well as a COS line and TX in and out audio, which means it could be used for an all-star node. But then some people are like, oh no, it doesn't have PTT, but they say it does, and it's used for like digital stuff, so it should have push to talk.
Yeah. I will push to talk.
If I could wire one of those up, just get that cable and break it out into a board, I could make an all-star node for it, and then just when I'm at work, I could use the all-star to actually talk into the repeater, which would be pretty cool, providing there's a signal, which there usually isn't. It's a shame. Still here. Well, if we're done here, I'm gonna close it down then, because
Yeah.
if Ian was here, we'd be going until 1 a.m. But since he's
3 in the
not,
morning.
yeah, 3 in the morning. If that's all for anybody, if Dave, if you have
Yeah.
anything else,
I don't have anything else.
I don't. I'm tired. Micah
Yeah,
needs to go to
right.
bed. So with that, I guess I will say 73s to everybody. Good night. Thank you for being here.
All right. Until next week.
Until next week, it is. Hopefully, we have a topic then. I think we will. Because it's gonna next week is gonna be me by myself too. But after that,